Now we will be starting with our next session, which is foundational blocks for smart grids. And for chairing the same, I would like to invite Mr. N. Murugesan, a former Director General, CPRI, and advisor ISGF, to the dais. A very, very warm welcome, sir, and thank you so much for chairing the session today. Mr. N. Murugesan, with 40 years of experience in power systems, transmission and distribution system, communication protocol for power systems, substation automation, distribution automation, smart grids, advanced metering infrastructure, smart meters, switchgear testing and certification as per national and international standards. And sir carries a vast experience, and it is my pleasure to have him on today for to be the chair for today's presentation session. So we will move forward with our first presentation by Mr. Manan Pathak. So unfortunately, Mr. Pathak is not here with us, but he has sent, Mr. Pathak has sent a recorded presentation to us, and I will just play his recorded presentation.
Dignitaries, my dear colleagues, I'm Manan Pathak, serving as an assistant professor in Department of Electrical Engineering, Silverbrook University. Today I'm going to give a presentation on the topic optimized design and development of cost-effective transmission line inspection robot. I'd like to thank ISCF for providing us a beautiful opportunity to represent our research article in Indian Smart Utility Week 2024. Let us just try to begin with the problem statement of our research project. What are the challenges that in transmission line that we are facing? We'll begin with the challenges in the transmission inspection. We all know that nowadays we are updating our transmission line voltage, and we have reached to 1200 kV HVAC, and at the same time we are working on 800 kV HVDC. Even 1100 kV HVDC transmission line are under scrutiny. So, there are certain challenges that we are dealing while dealing with the transmission line. So one of the challenges is assessing a remote area. Like transmission line often transfers through different terrain, and it making an accessibility a major challenges for the inspection team. Second, foremost challenges regarding the transmission line inspection is a weather dependent operations. So it totally depends on, in India we do have three different seasons. So the inspection activities are heavily influenced by the weather conditions, and again it leading to the potential delayed, and there might be a safety concern for the scene. Third major challenges that you are facing is data interpretation complexities. Processing a large volume of inspection data, it requires an advanced analytical and significant challenges, and being as a manual inspection that we right now dealing is quite difficult. And last challenges that you are facing is a safety risk for the personnels. As we are updating our transmission line voltages, and definitely the mast or the structure of transmission tower is day by day increasing. So manual inspection method that expose the workers with a hazardous environmental, and it leading to the safety and liability risk for the worker that are dealing with the transmission line inspection works. And even they might face different electromagnetic field related effects. So in longer time, definitely it impacts a lot in terms of safety issues. So what are the main objective of our project work? So the overview of this project reverts with the focusing on creating a cost-effective robot for the inspecting of transmission line. As in this diagram, if you can see, there is a person who is trying to verify, he is trying to inspect the transmission tower, which do have multiple components like insulators, cables, cross arms, and even it's quite difficult for him to verify the exact location of fault or at which particular place there is a need of maintenance. So the main aim of this research article is to optimize the design and develop a process to ensure the efficient and reliable inspection operation of a transmission line utility. It deals with an efficient inspection. It means while dealing with a robotic inspection, robot is capable enough to inspect the transmission line very quickly and accurately. At the same time, data collectivity will not be a major issue with the help of AI tool, like whatever robot that you are dealing with. They enable the robot to gather comprehensive data and for analysis, and they can go ahead with the maintenance planning. And lastly is the safety engagement. So again, as discussed in a previous slide, that the human being will not directly in contact with the inspection activities. So it implements the safety measures to reduce the risk to the human inspections during the transmission and inspection process. So, in general, if you can identify different factors that affect the transmission line inspection, it deals with the right of way. Definitely, depending on the transmission line voltage, it correlates different range. So, right of way, of course, is a big issue. Then, corona effect during rainy season, even during winter seasons, we are facing a corona effect. That to deal with radio interference, audible noise, and IO current. Even space charge will be the issue in case of hybrid transmission line concern related to electric and magnetic field and ground clearance and corrosion effects plays a very important role. So these are the factor in line with the same. If we can identify the design criteria to deal with robotic inspection, it correlates with an environmental adaptability, power efficiency, and in general the robustness of the robot design that must prioritize the usage of eco-friendly usage, and it must deal with some sort of operation and maintenance task which easily can be adopted by the person who are dealing with a manual inspection. So a layman or a labor can also get equipped with the usage of certain design of robot that we are supposed to use in transmission inspection. So, like just by implementing this robotic inspection, we do have certain advantages, as we all know that the efficiency while dealing with the transmission inspection with the help of robotic technology, it provides a high improvement in terms of overall efficiency. So again, a large distance can be accessed by the robotic technology, and within a few minutes or within few duration of time, we can easily able to identify the data. Second is accuracy. Second most advantage regarding the dealing with an robotic inspection is accuracy. So as it is equipped with some sort of sensors and imaging technologies, the robot that ensures the precise data collections and detecting the potential issues within the range and with an high accuracy level. Safety again will have a greatest advantage while dealing with a robotic inspection and a cost effectiveness. Yes, here it's again a dilemma, like if we are investing money on developing a robot which deals with a transmission inspection, again initial investment is required, but on a longer run, if you can verify, then definitely it plays in terms of pivot analysis, it can justify, then yes, this technology is quite cost effective, and definitely there will be less human effect in the transmission inspection process. So, what are the system architecture and which kind of components that we are dealing with, and which parameters we need to take care while dealing with this inspection robotic technologies? So, first and foremost is sensors. Of course, all kind of data needs to be verified, even while climbing on a pole or while dealing with some drone based technologies, which kind of components we need to detect, which environmental conditions we are dealing with, and which kind of data is supposed to be transmitted to the central processing unit. So some sort of sensor technologies needs to be imparted. Second is central processing unit. It means from the CPU process data it receives from the sensors, and the movement of robot with different inspection activities can be correlated. And of course, there are two way to coordinate the same. If a person sitting standing near to the transmission tower, and with the help of some wired communication, that robot is supposed to be traveled, and at the same time wireless communication with the help of drone technology, so some sort of power supply needs to be provided, either in a way of battery backup, and maybe such components will try to implement the inspection process very effectively. So, what are the inspection techniques that methodology that we can adapt while dealing with a transmission inspection. One is aerial inspection, of course, with the help of drone technology. A drone is equipped with high resolution cameras. So, with the help of thermal imaging, we can identify at which particular location there is a fault or there is a need of maintenance. Second is infrared thermography. It means from this technique, it employs the infrared camera that detect the abnormal heat pattern of a particular mast, and it deals with a particular location. So engineer only needs to locate that area, and within a specific time domain, it can easily try to identify the results. Ground-based inspection, as I mentioned, there might be a robot that need to climb through a transmission tower, and maybe through vehicle technologies that can easily be incorporated. And last is ultrasonic testing. It means with the help of ultrasonic sensors, they are utilized to identify the materials and it defects on a corrosion within the transmission line in a particular insulators, and it ensures the structure integrities of a particular line. So, in general, if you can see, this is a general transmission line diagram which consists of multiple components like cross arms, suspensions, then lightning shield wire, insulators, conductors, guy wire, and foundation block. So, we need to take care of each and every component. So, through a cost optimization parameter, if we can have a higher operational efficiency, maintenance planning, and budget maintenance, if you can correlate all three, then it can easily have a strategy to reduce the overall production cost, and definitely we can incorporate the high efficiency, high reliability, and the safety standards can also be matched with the same. So, in general, what will be the performance analysis? These are some images that may propose that certain diagrams or certain lying robots are also incorporated. This is applicable for like ultra high voltage transmission line, more than 765 kV for AC, and again 500 kV for HVDC. So certain diagrams will justify that how the robot will going to inspect the overall transmission line, and the range and speed of that inspection is quite effective in nature. And these are some thermal images, maybe with the help of some drone technologies, the overall line needs to be inspected, and at a particular location it can be identified with the help of thermal imaging. So there will be no issue in terms of different terrain condition, different weather conditions. Even the speed of inspection will be high, and the accuracy in terms of data can also be incorporated very effectively. Uh, some issues with cost effectiveness analysis in terms of traditional inspection and in terms of robotic inspection, some comparisons are being shown, and which deals with some factors like cost of equipment, operational cost, downtime, and accuracy. So in line with the same, all parameters needs to incorporate it, and with the help of robotic inspection and traditional inspection, both data can be incorporated, and at the same time we can correlate the overall idea. In general, like as a futuristic vision, the development, of course, we know that in India we are now going with the help of hybrid transmission line optimization, and again the we are improving the transmission line voltages. 1100 kV HVDC line will be there, and again 1200 kV HVAC line in between Bina and Madhya Pradesh is been now actively working. It's live now. So there is a need of transmission line inspection, and if we can go ahead with some robotic technology, then of course the workload on a particular person will be reduced, and we can go ahead with good data accuracies and time management. So it's all about the enhanced navigation system with the help of some sort of AI tool, with the help of sensor technologies, so-called advanced sensor technologies. We can easily incorporate the same. Second, it deals with the integration of AI for the data analysis. Of course, AI plays a very important role nowadays. We all are familiar with the usage or impact of AI in almost all field, and one of the field will be this transmission inspection that can also be incorporated. And lastly is expansion of robotic arm capability, maybe with the help of climbing robot or a flying robot that can easily be incorporated, and we can correlate with such certain futuristic development for the same. So in last, the overall concluding remarks regarding our project work. So we conclude that our discussion is to optimize design and development of cost-effective transmission line inspection robot. Some of the prototype models has been developed, and through that imaging, we can easily able to represent the same. By leveraging the capabilities of the robot, the organizations can significantly enhance the efficiency, accuracy, and safety of a transmission and inspection. So again, different utilities can adapt certain practices, and it needs to be identified because nowadays data plays a very important role, and if we can have a correct data of a line, then definitely we can provide a good efficiency and provide a better performances of an individual state. And the successful implementation of this project opens the door of future advancement, and automated inspection technologies will promises the safer and more reliable operations of the industrial time. So with that as a concluding remark, we are concluding our presentation, and again, these are my contact details. Due to some unavoidable circumstances, I am unable to come in present, like in person, to give a presentation. Again, like in future, let us have some collaboration. We are working on the same, and being as an academician, it's quite a good opportunity for all of us to like incorporate ourselves with some real-time project work. Again, would like to thank ISCF for providing us a wonderful opportunity for showcasing our research article for the same. Thank you very much. Good afternoon, respected dignitaries, my dear colleagues. I'm Manan Pathak.
So, would like to thank Mr. Manan Pathak virtually for the presentation, for the virtual presentation, recorded presentation that he has sent it to us. Mr. Pathak has also shared a PPT version of this presentation, which will be shared later with all of you. Now, I would like to invite Mr. Pankaj Prabhat from GE Digital. Mr. Prabhat has 6 years of experience in power systems, and he's been working with GE from the past 5 years. So without any further delay, would like to hand over the stage to Mr. Prabhat. His topic is automatic generation control of BESS alongside conventional generators with power, with market interface. So over to you.
Friends,
I'm so sorry. Before Mr. Prabhat's presentation, any remarks from our chair on the last presentation?
friends, so the technologies, whatever discussed virtually from the Silver Oak University, is known to everybody. The only thing is that now we can able to integrate. Previously, it was a standalone. Now we can integrate it by data and all such things. The machines are available, so it become easier. It's a good paper. And friends, actually, we are falling short by one session. This by this time, no, the first session would have been over, so that much time we will overlap. So I request all the speakers. We have about 10 speakers are there. So even if we put 10 minutes instead of 15 minutes, even then it will go to 2 hours. So it will be unnecessarily people have to go here and there. So I request all the speakers to confine to slightly faster, only 10 minutes. 10 minutes means 10 minutes because the previous speaker, he was recorded once, we could not able to interrupt it. So kindly cooperate, otherwise it will be too late from leaving this place. Thank you very much. Over
Thank
to
you. Thank you, sir. So I'm Pankaj Prabhat. I'm from GE Digital. I work with a team which provides software solutions to utilities. Uh, and this is a very small case from the bigger offering that we have provided to a transmission operator somewhere in Singapore. Uh, we provided a transmission, the EMS and GDC systems uh, to, uh, to a transmission utility. Uh, and this is not a very big transmission utility, but they are integrated with market. They have a lot of renewables resources. Okay, uh, they forecast their solar, any kind of renewable resource that they have. They send it out to the market. Market sends back the schedule for all the conventional generators which they have. Okay. Now, since the forecast cannot always be accurate, and on a daily basis, they do this at a frequency of 30 minutes. Now, since there will be some kind of difference, right? To mitigate that, so far they were, everybody uses the generators which they already have, and before we go there, I want to show you something. Yeah. So the market schedule that they get, okay, they get several operating points, okay, starting with, the minimum and the maximum limits at which the generator can operate, okay. Along with that, they get the actual base point for that particular hour or for that particular duration in which the generator is supposed to supply, and then a very thin margin where the generation can be changed. So the delta P. Okay, so the high-low regulation limit that you see in this picture is the smaller region where the generations can be changed, but the generators normally do not exceed beyond that unless it's a very special event. Okay. So here to address the power mismatch, the concept of BSS was introduced, and this BSS, as you know, like it will be controlled autonomously or anything, but we integrated and we enabled our software to control the BSS with the same software with which we were controlling the other generators. Okay. So the background of this GDC software, so there's a component called AGC, okay, automatic generation control. Its basic objective is to reduce ACE, area control error. Okay. Now to control the generators, we divide this ACE in 3 regions, okay, to take actions based on the area control error. We divide it into 3 regions, okay. If it's not very high, so the bands that you're seeing in this picture, if the ACE is very small, okay, so we define a range which is called as normal region. So if, and this region is normally very thin. So in this region, we normally do not give out any control from the software to the generators. Okay. Then we have this regulation region and emergency region. So among this, the emergency region is somewhere within which the system cannot stay for long. Okay. This can lead to cascaded failures and ultimately the total grid failure. And then these are some, after implementation, we observed its effect on the production cost and overall, the stability of the systems, to which will come later. But to include the BSS, we took some constraints in mind. Okay, so among them were the SOC. So that is first and foremost. So SSC is up to like the minimum SOC we keep at 20%, which is configurable, and the maximum we are going up to 80%. And then apart from that, we had to enable that this battery system should aid in case of any emergency. Whenever there is a requirement, it should be able to aid in maintaining the stability of the system. So in this case study, we just we picked few conventional generators and 2 battery sources from a very large system, and these were the parameters that the system got from the market to maintain. Okay, and at that particular time, the total ACE was minus 91. So if it says minus, it means you are under generating. You have to ramp up the generation. Now, so the basic objective here will be in this problem to find a new base point for the all the generators plus the BESS, and then the software would send out pulses to the generators and the BSS to ramp up their generation. So to do that, first step is that we understand what our current, what is the state of the system currently, and then we start calculating the participation factor of the generators. This participation factor is calculated based on the limits that for each unit that we have received from the market. And for this, they also took a more conservative approach, that if the ACE is not too high, okay, when it can be managed by the conventional generators, let's first try to manage the disturbance through the conventional generators. If they are not sufficient in this region, then we bring in the BSS. Okay, this is done to save the charge basically, so that if you discharge now, you have to manage the charging back. So based on this, we calculate the participation factor in the regulation region first. This is done in two steps, where we first calculate for conventional generators and then for the BSS. Once this is done, then we calculate again UCE. UCE means unit control error, right? So this is the difference which the generator has to fill up, okay, to stabilize the system, right? And based on this, the new desired generation is calculated. So which is nothing but the old generation plus the new calculated delta generation that has to be changed, updated. So based on this, we calculate. So this is first done in the regulation region. If doing this much change, the new base points are not able to meet the requirement, they're not able to meet the gap which happens, then we move into the emergency ACE region, okay? And there again we follow the same loop, but instead of doing a two-step process, we do just one, okay? Because at this point we want to utilize all our resources, and we do not want our system to be in the emergency state for longer. So for this, we try to pull out as much generation we can, or to supply as much we can to mitigate the ACE. Okay? And so finally, we are able to achieve that. We are able to meet the generation requirement. We are able to adjust it. And at the same time, we also observed some significant improvement in the production cost of the power. So this is the generation cost which got reduced after implementing the BSS in the system. So yeah, thank you. Any questions?
Yeah. Thank you very much. Kept up his time. It's a good, interesting topic. And we have small question is that how do you, again you have to charge this battery?
Yes. So initially that battery is also scheduled by the market. But okay, if any situation happens where you have to charge or discharge away from the actual, the expected state, in that condition, there will be a correction again for the schedule to charge it back. So we maintain, and it is configurable again, that what state you want to, at what SOC you want to keep the battery for now. So whenever there's an opportunity, if you are having a load power deficit scenario, you can have a situation where you have extra power too, right? Okay. So during that time, we charge back.
Okay. Yeah, any concept is similar. It's good. Thank you very much.
Thank you.
The next speaker is from Tata Power. Please.
We have Mr. Dilip Singhal with us from Tata Power, Mumbai. Mr. Singhal is a GIS professional with over 20 years of experience in the field. So I would like to hand over the stage to Mr. Singhal now. Over to you, sir.
Good afternoon, everyone. Myself Dilip Singhal from Tata Power, Mumbai. So my topic is common GIS map for all domains in smart city. So in the Mumbai, actually all the electric network is underground. So all the utility are facing the issue due to the unplanned excavation, which leads the GIS cable fault, and due to that there is the outage to the customer. And it will be incurred the cost to repair the fault. Then indirectly or directly it will be lead the traffic to the end customer as well as impact to the customer. So all the utility in the Mumbai, they are maintaining their own GIS, and like Tata Power, MCGM, Adani, BEST, Mahanagar, and Jio. So they are maintaining their GIS. So they are incurred multiple AMC cost, development cost, time, and IT infrastructure. So it will be lead to the duplicate efforts in collecting field data and other variation data related to land base as well as their own utility. So why the need of this common GIS? So if we have the common GIS, then it is very difficult to comprehensive infrastructure planning if there will be no common GIS. Then for the project execution, so issue related to the infrastructure overlap, conflicts, and it will be increase the project cost as well as slippage of our completion time. Then for the resource allocation, it will be very challenging to prioritize and allocate the available resources and to use them effectively. Apart of that, there is the regulatory compliance which will be lead to the potential legal and regulatory issue, and this can impact both the utility and publics. So, like I said, we have Tata Power Mumbai have implemented the GIS in which we are cover around 485 square kilometer area extended from Kolaba to southern Mumbai, Vasai Creek. So we have developed our own GIS in which we have firstly prepared our land-based map, then we have marked our administrative boundary to facilitate the customer, then we have added the business support land-based layer related to buildings, built up, roads, etc. And then we have mapped our business entity like distribution network, transmission asset, customer location. So by implementing the GIS, Tata Power is using thoroughly the GIS, which will be beneficial not only Tata Power distribution, it will be help to the other other subsidiary of Tata Power like Tata Power Solar, EV, transmission and generation groups. So it will be benefit to Tata Power for planning and execution, for providing the new connection to end customer, operation and maintenance, for fault location, maintain that one. We also provide the map to MCGM for annual excavation plan because it is overall underground networks. Then we are also sharing our network or map with the MERC for understanding the past and future planning of our network plan. So by this we are proposing a approach, a common GIS map in which this map is prepared by the MCGM and it will be shared to the all the private utility and other government utility through API, in which the GIS database is stored at MCGM level and communicate through web API. So the benefit of this common map is it have the common land-based language to all the utility, and it will be help for planning urban planning. Then there will be minimum interruption of public services. So and integrate data sharing through by MCGM. So it will be help if there be any planning or anything and any utility take the permission on a single portal. So the key takeaway is if we implement that one, so it will be facilitate seamless data sharing among utility, and it will be give the holistic view of city infrastructure. It's directly help to the public so that they come to know what is the infrastructure project is going on, and it will be increase the public trust. It's also help to provide the accurate land data, enable tracking of our queue team members, so it will help for the workforce management as well as reduce the response time. Then streamline urban planning, it will be allow the better coordination between stakeholder, improve infrastructure maintenance and resilient cityscape. So to implement this one, this is the matrix in which a municipal body and private utility can go ahead to create this common GIS map. In this one, firstly, standardization of land-based data for Mumbai region or any smart city region, then private company and municipal company can define what the land-based data model we have to require. Then, based on that one, existing land base can be updated. And after that, they can, MCGM or municipal body can develop a web API, which is used by other utilities, and based on the API, so each utility can standardize their GIS map. And after that, there will be a joint responsibility of MCGM and utility to which data we have to publish on the public domain. So it will be a win-win situation to all the parties, government party and private parties. Thank you for this.
So thank you very much. Within 10 minutes you have completed. You have any question on this? Yes, yes.
Yeah, I'm Abhijit Joshi from Torrent Power.
Yeah.
So you have already implemented this GIS.
Yes.
So what is the percentage, like the accuracy of your GIS?
Yeah, our sorry. Our accuracy is more than 99% because we are updating our data regularly, and to update our data we have integrate our GIS system with other department. Okay, like for our meter level mapping, we have mapped our GIS with ISUW. So there will be our automatic application through which the meter which are installed, remove or replace in a particular day, through the SAP integration, it will be automatically mapped or update in the GIS. For the network updation, we have our M5, M6 notification, which will be the part of SAP, and through that one we are getting that trigger point and the information.
So like in your ringmain, if you do changeover, that is also getting updated?
Yes, it will be comes in the changeover also.
Okay, and then already Government of India is also having that portal for, so you're not participating in that portal where you have to superimpose your data or your GIS into their network?
Yeah, that's point is this one. Government have their portal also, they have their own GIS map, but the accuracy or the data, they have availability of that data is not as accurate as we expected. Like suppose in the buildings, they have marked the building as in the Mumbai there is a complex which have suppose 20 or 40 story buildings. Okay, so they have marked only one parcel and that only society name. But in here, as a electrical utility, we want how many number of floors are there, how many wings are there. So that information we require. That's why in my previous slide, I have mentioned standardization of land-based data for Mumbai region. So it will be the responsibility both for municipal corporation or MCGM and utility, which are actually make this data which is used by all the utility.
But like, have you highlighted this issue to the government portal?
See, we have already discussed this one Okay, but you know, sometimes we are getting some information, we have to meet them, we have all to do this one, already informed that one, but as of now, we are not a concrete handshake with them.
Thank you. Thank you.
Yeah.
Good. Thank you very much. Thank you.
Thank you.
So next up we have Mr. Moreshwar Salpekar with us, Architect Systems Engineering, Savia Multimedia Private Limited. He has over 23 years of experience in the field of embedded systems and has also worked in with electric vehicles. So I would like to hand over stage to Mr. Salpekar. One more thing that I would like to highlight about Mr. Salpekar is that he's been submitting his papers from a very long time in ISUW 2024 technical paper submission, and his papers are so well written that they always get selected in ISUW. So without any further ado, I would just like to hand over the stage to Mr. Salpekar. Over to you, sir.
Okay, so I am Moreshwar. Just before I began out, I think that I have a hearing problem. I won't be able to take up the questions from the crowd. So if you want, I will ask personally one-on-one, or you can write up and give me. I will answer other of them at the best of my knowledge. Okay. So, okay. So what the proposal, as you can see, is that India is we are already in the midst of moving to electric vehicles. They are electric vehicles because they are supposed to be saying that we want to save power, we want to save energy. On the top of that, we are also committed to Paris Agreement for climate control. Yeah, there. And also, our government is already saying that we want to be a developed country. So there are three main reasons. So that we have to move towards smart grids. Smart grids are going to help. They are expected to help us to save power because it will be needed sooner or later. Save power, you want to augment the power. By augmenting, we have limited land capacity. We don't have indefinite land. We don't have indefinite infrastructure placing capabilities. So we need to utilize whatever we have with us. How we can use, for example, you have smart IoT, Internet of Things. It's basically a communication, sort of communication protocol. We have subsystems, etc. in IoT. Then you have smart buildings. Smart buildings build upon IoT and have other parts so that you can manage your supply building network locally instead from within the building without any dependence from outside as much as possible. Then you have microgrids. Microgrids, there have been a lot of papers presentation today only that microgrids have a demand and supply, both sides in their own. They can be isolated, they can be connected to the grid, whatever you want the way, you don't have restrictions. So what we are trying to say here, do here, we have residential building, you have commercial building, we have enough space on the top to place rooftop solar module and the battery infrastructure related for it for storing the solar power. This is the scenario we are thinking of. the scenario as you have in housing, we want to develop nation, we have developed nation, industries coming up, infrastructure coming up, every electric vehicles already are coming in. You cannot keep on building new power plants. And for fossil fuels, everybody knows we have limited supply. And then also we have, we are already complaining that they have a pollution. There are a lot of pollution. People are saying that this is polluted, this is polluted, this is polluted, everything is polluted. So we need something out of that. So that brings us to sustainable development. Sustainable means our future generation will say that, okay, this was done, this is good. Now, in contrast, to contrast this with what the European Commission says that buildings are responsible for 40% of energy and 36% of greenhouse gas. This means for 40% of electricity produced is going to these premises, and they give out gases, GHGs. Plus, I don't know how many people you are coming by your own vehicle. If you have parked them, they are idle. So if you have more electric vehicles, all of them parked, not no use. Some of them you will have leakage in the electricity. Battery leakage is obvious. You cannot isolate them. That is another thing. So why not? Now, what we saw, there is already research going on. This was the first paper that I saw, the first top one, grid interface solar. This is coming from IIT, IIT Delhi, Dr. Bhim Singh. I'm not sure how many people of you are aware. Dr. Bhim Singh is a good authority, as I know, on these parts. Then you have IIT Kanpur is also doing research. There is another paper from IIT Delhi 2023 that I have not mentioned here, because I have done a lot of things. So, plus, if I'm sure everyone of you have read that the government of India is saying if you PM Surya Ghar mein Muft Bijli means you have your own generators, electric generator, you use them, you supply, you are free. So what it just makes me think, why not use this? They can obviously use this to have augmented supply. So for this is a very simple diagram. There will be a lot more to here than what I have drawn out. So, but the main part is I have macrogrids at two levels. The building itself, module itself is a macrogrid because generating and consuming both. Then combine them with multiple buildings and a macrogrid control center. You will have another level of macrogrid. Two levels I'm thinking of. Of course, you have a hierarchy over there. So this is what I'm considering. In your buildings, you have the essential buildings. What I say, building has one master controller that controls the whole of building. Each of the units, dwelling units, or industrial units, whatever you call them, have their own IoT modules that will read your data, that will take measurements based on the sensors, provide to the lower master building controller. I call it BCS. And this BCS communicates with the top level microgrid controller. The top level microgrid controller knows what is the state of each building, what are the state of the aggregate, whether this can be used to augment the grid supply. It depends on the protocol they have defined. They are not neither hard protocol, there is a soft protocol. You can define your own protocol, but this is what I am proposing at the simplest level. What my protocol, I am making this finite state machine. This is the FSM. On top you can see installation, activation. When you install at the top level, you have nothing in the rooftop modules. Your building is not charged. Then you perform the initial connection. This will communicate with the microgrid controller rooftop module. At the end of the initial connection, the rooftop module will be charged so that with solar power, it will be storing some power. From that, you have when you charge, you can go to the or while it's being charged, you can get the power from the grid. That's the grid integration. And once the grid is charged, or you have a completely charged rooftop module, you can obviously say that, okay, grid, I don't want your supply for now. I can use my own supply for the moment, depending on actually the building control unit or building control system will compute how much it can do with the power or how much it can use its own power. There's the dynamic, it's not certain. It depends on how much is the battery charge and what is all connected at the end, at the consumer end for the building. It's not hard and fast that way. So once it's independent state, from the independent state, once you are below threshold, you will go to the grid setback. Because when you are below threshold, you cannot do anything with independent. Of course, you have battery charging for the rooftop, but still there will be some thresholds. You have to follow them. Then from that, other condition is, let's say the microgrid controller says, I want power from you. It can complicate with the building control. Okay, are you in a position to give me power? If you are in a position, how much power you can give? Depending on handshake, you move supply to the grid state. And obviously after threshold cross, you move to grid back. So that is the final state machine here. Just to give a sample, Mark building getting power from the grid. Rooftop batteries are fully charged. The smart building module by itself detects that there is a loss of power from incoming grid. So what it will do, it will switch to building in a state, and EV charging depends on what protocol you agree. EV charging can be done, cannot be done, okay? And that is this case. Now, thing is, just going to the key takeaways for a short time. The grid, do with the smart building and grid. This is, you can, as we also said, we have 40% and 36% effect. The demand may exceed supply. How long you can build power plants? Not possible. Smart building can augment. You only think requirement is cooperation between the two buildings, cooperation between the people in the building. If two people say me first, obviously the system is not going to work. It depends on cooperation. Then you have privacy. Privacy means data is not going to be shared unless needed. I don't want my data to be used anywhere else. And maintenance, obviously maintenance and prompt is required. So that's it. I know it's a very lot to be discussed, sir. Lot of things. So,
there are any questions, we can take it. We can always take it over coffee and tea. So before moving to our next session, I would just like to invite all our participants again for a memento distribution. I would like to invite from Silver Oak University, Mr. Manan Pathak. Since he was not here, we have a representation from Silver Oak University on the behalf of Mr. Manan Pathak. Thank you. Mr. Pankaj Prabhat from GE Digital, thank you so much for the presentation. Mr. Dalip Singhal. Please, okay, so he's not here. We will have it sent to him. Mr. Moreshwar Salpekar, please join in, sir, for the memento distribution. Thank you.
Yeah, you need a special appreciation. You're doing good work. Thank you.
Thank you. Thank you so much, sir. So now, without any further ado, as per our chair's suggestion, we would, without breaking for any tea or coffee, we will be moving forward with our next presentation on unlocking the value of street lights for multiple smart cities application. Mr. Sairam Kumar, team lead, Accenture Technology India. But before that, I would just like to mention that, would like to highlight that two papers on the same topic were selected because they were so well written and the insights were so grounded that both were selected. So we would be having Mr. Sairam Kumar from Accenture on this topic, and after him, we'll also be having Mr. Gufran Basit, Solution Architect, Siemens Technology Software Private Limited, on the same topic, unlocking the value of street light poles for multiple smart city applications. So without any further ado, I would just like to hand over the stage to, let me just look for the this one.
No, the other one presentation file.
Maybe 22. It's not this one.
Template, sorry. Template one. Oh no, this one. This one's looking to be.
Do you have it? Do you have it in the pen drive? Do you have it with you?
I have a laptop. Will that work?
No, I'll just check.
I don't think I can connect my pen drive with the laptop. It is not. I'll just not see.
Yeah. So can we start with Mr. Gufran first? Then can we go? Can we just?
Yeah. Can you just pen drive one?
Yeah. So due to technical issue, we'll be now having Mr. Gufran's presentation first. Apologies for this error. Over to you, Mr. Gufran.
Thank you, Parul. Hello. Very good afternoon to our esteemed audience. Myself, Gufran Basit. I am working with Siemens as a solution architect. I am handling a portfolios which are related to great softwares, and my core expertise in MDM, meter data management system, and DER controlling and monitoring. Further, I would like to thank ISGF for providing me this stage, and I'm really happy. Like last time also, I have submitted my papers. It was got selected for abstract only. This time, I have submitted 3 out of 3, got 2 for the publication, and 1 is for presentation. So today, I am going to present that topic. Okay, let's start. In the tapestry of urban transformation, these become as a part of our daily life. Any guesses what is this? Okay, let's delve into a topic that often goes unnoticed but holds immense potential in shaping our urban environments. Truly, these are unsung heroes. Any guesses now? Okay, these are our humble street light poles. So during this presentation journey, I request you all to join me as we unlock the value of smart street light poles for a smarter and more connected future. I will talk about few on the topics. One is features and capabilities of smart street light. We'll also talk about market overview. I'll touch upon some market segment of the smart street light. We'll try to showcase to the proposed solution how these smart street light system can be implemented and a small architecture. We'll try to show some case of benefits if we adapt all these applications. And lastly, but not the least, we'll also talk about the challenges. So let's start with the introduction, and the main introduction for the smart street light. I would like to highlight what are the features and capabilities of any smart street light. Here you can see any smart street light should have a capability of turning off and on. Should also have a option for a dimming. And this dimming can not only be limited to manual, it should be auto dimming as well. And when I say auto dimming, it depends on the weather condition. There should be a capability of real-time monitoring and controlling. There should be a capability of fault and alarm monitoring and its resolution. Having said that, if we implement any smart street light solution, then definitely it also gives some other features and capability which you can see on the screen. It will help us to manage the traffic system. In addition to that, it will also help us to implement the security system more robust. Along with that, it helps us to make any EV charging option. So these are few capabilities and features which I have been highlighted over here. Going ahead, let's talk about the smart street light market currently in India. So here, as you know, we have a smart cities initiatives are running by our government of India. And smart street light is one of the vital player which definitely helps to boost the smart cities initiative. And here you can see from the 2020 till 2023, the growth is exponential. So it's almost more than 10%, 11%. Definitely I don't have any updated data, but the data which I got collected is around INR 5 billion by 2023. And definitely why this is increasing, as you know, there are a lot of schemes are running by Government of India, some of Ujala schemes, some of Street Light National Program, SLNP. There are so many campuses or townships which are going towards more smarter and become more smarter in terms of handling the street light as a smart. So let's talk about what type of market segmentation these smart street light can cover. So this can be divided around 4 quadrants. One is a small private, small public, large private, large public, and large private. So how these has been categorized? Here you can see these has been categorized depending on the number of poles you have installed in those particular areas. So when I say small public, so it's like a very small thing which is like a municipality. If I would say a large public, which is a smart city, which having a more than 20,000 poles within that vicinity. So this is a market segmentation which is growing and which is definitely enlarging day by day. So having said that, we have a market segmentation, how we can implement in which type of area, what type of poles and street light poles we needed. Along with that, there is a solution which we have come across, which is like depending on the which type of market we are going to deal with. So mainly there are 2 type of solution which can be covered almost all type of smart street light. One could be a group control mechanism and one could be an individual control. So when we say group control, definitely it's like a group controlling of a smart street light which are on a roads or which are, you can say, on a township or a campus. Individual street light can also be controlled depending on the particular small area. So there are two types of solution which we can suggest over here. In the same way, if I'll go a bit deeper or deep dive the architecture of this solution, then definitely there are multiple technologies or communication technology which involves how to gather data from the smart street light poles. It could be as an individual basis, it could be from a controller basis. So there are mainly controller which generally like used. One is NEMA controller, Zaga controller, pole mount controller. In the same way, the street light poles can send data to a system using multiple communication technologies depending on the type of usage or depending on the number of street light. One is RF mesh, one is LoRaWAN, UNB and PLC. So having said that, so there is a small pictorial diagram of this solution architect. Here you can see this is showing a group controller mechanism. So where there are group of smart street light which are sending data via RF communication technology to a feeder panel, or you can say a controller. Once these data can be collected over here, then this could be sent to any sort of software, be it a SaaS-based software or be it a on-premises software. So this is a smart street light application, I would say. So for this, we can use any sort of communication protocol. So here I have taken example of MQTT. You can use IC104, Modbus, whatever, depending on the vendor whom you are dealing with. This is a proposed smart street solution architect from my side. Now, let's talk about few benefits. If we adapt this smart street lighting system in our day-to-day life or making our smart cities more smarter, what are the benefits we are getting with? So here you can see definitely it will increase the option to generate the revenue. How? Definitely will control the street light, we can save our energy. We can optimize energy cost uses by applying controlling dimming. This will also help us to intelligently architectural planning depends on actual road traffic pattern and vision. This will also help for a better experience for a pedestrian. And definitely not but the least, it will also save us carbon footprints. So this is some benefit which we can make out of this smart street light system. So we have talked about so many things about smart street light, but definitely it's not the easy or the cakewalk. There are few challenges. There could be a few bottlenecks which government or anyone has to deal with. So I have just touched upon few challenges which definitely this is an idea and there are counters of these ideas. So mainly is the challenges which I can note it down here. First of all is the funding. Definitely we have a lack of budget or financial planning by the government. So we need to make sure that how much this funding could be generated. Proprietorship, there should be a propriety or ownership who will take the ownership of the utilities. The legal issues, the logistic, and most of the important thing are cyber security. Definitely if we will make our system more smarter, there is a fear of hacking of a smart street light. So this is all the challenges which I have noted down over here as the time is running out. So let me conclude. So before I conclude, I'll say there are plethora of application which makes any city smarter, but smart poles always make a vital role. So to conclude my remarks, we can say smart street lights stand as a silent sentinels of urban progress, which offers boundless potential for multiple smart city application, and it will make our future more interconnected. Thank you. Any questions?
Thank you very much. We thought poll was a simple thing, but it gives a lot of value additions, and the legal issues also there. So quite interesting. Thank you very much.
Thank you so much, Mr. Gufran, for the presentation. Again, I would like to welcome Mr. Sairam for his presentation. Yes, over to you.
Hello everyone again. Hope I'm audible. Thank you sir for giving me this opportunity to speak in front of everyone. And I'd like to thank my mentor Meenakshi and Lopa and my co-presenter Surya. Without their help, I would not be able to publish this in ISUW conference. So, and thank you Gurfan for setting up a idea of what exactly smart street lights can do for a smart city. Let me go into the topic directly. So India is going through a digital revolution currently, and with the Honorable Prime Minister introducing many new programs as part of the Smart City campaign, there is a program called as Street Light Fittings, which got launched in 2016. So as part of this program, Honorable Prime Minister wanted to completely convert the old methods, that is the CFL streetlights, the metal halide streetlights, and also the sodium vapor street lights into LED lights. Now, why LED lights? We've been hearing about LED lights for quite a long time, and we do get the question like, why not the other lights? The reason why LED lights are so famous or so important is because they are long lasting and sustainable, and also they have the unique feature of dark adoption mode for humans. Now, what is dark adoption mode? So, for example, when a human goes from a dark room into a bright room, so we do tend to adjust our eye for quite some time. But in the case of LED lights, it is not the same. Dark adoption mode is the unique feature of LED lights where it will be easy for a human eye to adjust itself directly to the LED lights. Now, this covers the introduction part. And coming to the main part of what does a street light do and what is the smart street light. Now, before we get into that topic, we need to cover three important aspects, which is the selection of light. Now, as I mentioned earlier, these are the different types of street lights which are currently being used, which is the high pressure sodium and metal halide bulbs and etc. And if you look at the working hours of LED light, it pretty much is what covering the entire life cycle of a street light. Currently, street lights are being run. Working hours of normal street lights range between 20,000 to 30,000 hours. But on the other hand, LED lights have a range of 50,000 to 100,000 hours. And also the brightness, which is something about the lumens. So the brightness is also can be something which can be adjusted as our previous author mentioned, auto dimming, which is an important aspect. And the next comes the control mechanism. So what is the control mechanism? How do we control the LED light? Not from the area, but from somewhere else. So that is the part of the control mechanism. There are different control mechanisms which are currently in place. Now, one is actually the Zigbee light link, which is pretty common all across Europe. So Zigbee light link is a mechanism or a framework where it gets connected using the 2.4 gigahertz, which is the common wave frequency for all the different connectivities for LED lights. And the other is Li-Fi, light fidelity, or the commonly called as visible light communication. But the problem with these two methods is that the 2.4 gigahertz range, where these two methods or frameworks are implemented, are quite crowded. It is like every other connectivity method are completely going into this particular framework only. So there is a different method now, which has been introduced called as Z-Link. Z-Link operates in the ultra high frequency band 985 megahertz. And this is something which is coming up in North America and South America, and currently in India there are quite a few cities which have implemented this. Now let me go to the video which will explain actually what it is. So there are two solutions here. If you look at the first solution, there is a central PIR device, which is passive infrared device there, and so this is solution one. I think I went quickly. Yeah. So the PIR sensor device, what it does is actually it will look for any blockade, or if any device comes in contact with the PIR device, it will send a signal to the other street lights which are connected in the parallel connection. So I think it can run for some time. Let me just.
Power supply.
नहीं आ तो रहा बट यहाँ पे शायद दिखा नहीं रहा. हाँ अब आ गया. Yeah, now it is. Sorry everyone for interrupting that. Yeah, let me just go back a bit. So this is the PIR sensor which we were talking about. And the PIR sensor acts as a master control device and the others act as a slave. So whenever any object comes in contact or not contact, or if it blocks the area of the PIR sensor, it sends a signal to the slave devices to switch on off or auto dim based on a specific delay. So for example here, you could see a small car entering into the area. Now at this moment, the very first street light got its luminescence increased, and similarly with a delay of 2-3 seconds, the next street light gets its luminance increased, and so on and on. Now this is a solution 1 or solution 1 approach which is currently in place. The problem here is actually, now there are certain areas, for example, if a human walks in. Now humans tend to walk at different paces and different speeds. So the delay doesn't work in same aspect. So that is why the solution 2 is being proposed here. Now in solution 2, instead of a master-slave control mechanism, we have different sensors at each and every street light. So each and every street light itself acts as a master device, and when an object reaches its particular area, it switches on, off, and it auto dims accordingly. And with the help of this, the master-slave mechanism is eradicated. Now, how do we control this remotely? So every sensor has its own GPS device attached and also has its own IP sensor device attached. So whenever for example, if there is any issue happening in one of the street light, any citizen can go and scan the QR code present in that particular street light, which will in turn send a signal to the local SaaS application. And from the SaaS application, it will in turn send it to a service order where the person can come in and then get the street light corrected. So this is a solution 2 which is currently being proposed and which is currently being implemented across the globe, but this is still in a very high level is what I can say. What are the future considerations for this? So streetlights not only having auto dimming or not only having the auto switching on and off, there are multiple applications. Now, for example, the applications can be where we can use artificial intelligence and to predict how the traffic works and where can we increase the traffic signals and where can we increase the efficiency. And the other is where we can use, if there is a large street light pole, these can be used for electric vehicle charging also. And also this optimizes sensor technology because we are using a same kind of a sensor in multiple parallel or serial connections. So that will reduce the cost and also increase the performance additionally. Now with this, I conclude my paper. I think I finished before the time, sir.
Thank you very much. Actually, we are happy that we have taken both the paper, but the perspective and focus are different. So we feel happy to introduce both the speakers. Thank you very much. Wonderful.
Thank you so much, Sairam, for the presentation. Let me move forward with the next presentation by Mr. Ankit Jain. So, Mr. Ankit Jain is working with Hitachi Energy India as Head Marketing and Sales High Voltage Services. and with over 13 plus years of experience, industry experience, Mr. Jain has done electrical engineering from Dr. APJ Abdul Kalam Technical University and diploma in management from IMT Ghaziabad. So without any further ado, let me just hand over the stage to Mr. Jain.
This is not other one.
Second. Yes. Over to you.
So, good evening, everyone. I am Ankit Jain on behalf of Hitachi Energy and my other authors, Francisco, Freddy, and Samuel, who could not join me today. I would be taking you towards our technical paper on carbon neutrality for high voltage switchgear. First of all, I would like to thank ISGF and chair of the session for providing us this opportunity where we can present how Hitachi Energy is actually contributing towards the carbon neutrality. In our industry, SF6 gas, which is sulfur hexafluoride, has been a norm for the electrical industry due to its excellent capability in terms of insulation and switching capabilities. However, SF6 is also known for having a high global warming potential, which is a recognized fact. And as we move forward, the impacts on the climate change are more visible. This is where Hitachi Energy plays a significant role, where we intend to develop a portfolio which is SF6 free without compromising on the reliability, scalability, and compactness of the high voltage switchgear. So, Hitachi Energy is pioneering innovation in terms of SF6 free high voltage switchgear, and this is represented by our Econic portfolio, which is SF6 free essentially, and based on the mixture of fluoronitrile gas along with the other gases. As we take it forward, I would like to present the high voltage roadmap for Hitachi Energy under Econic portfolio, where you can see that we already have the products which are commercially available as a part of Econic portfolio. If you see on the left hand, the first column, these are the products which are already commercially available, installed across the globe for Hitachi. And we also have the planning to improve the performance ranges for 2024 and beyond. My focus area today would be on the last row, which is retrofill for GIL. This is also the topic of our paper, wherein Hitachi Energy developed this retrofill solution in 2021, and we already have done a pilot project in the UK with National Grid. First, before dwelling on our retrofill subject, I would like to also mention regarding the relevance of this topic, where in post-COP21 era, environment and sustainability is a priority area for the government of India also. We now have a quantitative targets in terms of carbon emission reduction and also to being a net zero emission by 2070. Hitachi Energy portfolio, Econic portfolio, I would say, caters to this requirement where our products will be supporting for the reduction of carbon emissions from this switchgear. It is also evident from India's third biannual report, which was submitted to UNFCCC, that 75% of the carbon emissions are contributed from the electricity sector. And India also reports SF6 gas among the greenhouse gas inventory annually. Coming to our topic of retrofill, we call it retrofill, and this is not a retrofit because we are not dismantling any of the existing equipment. We are only replacing a gas, SF6, with a new eco gas, which is a mixture of fluoronitrile, nitrogen, and oxygen. To dwell on this further, in any typical GIS installation with a GIL, 50% of the SF6 gas is contained in the GIL bus duct. If we are able to you replace this SF6 gas from the passive component that is a bus duct, we are able to remove the 50% of the SF6 gas from this network. So this is where our retrofill solution comes into picture, which is applicable for replacement of SF6 gas from the bus duct specifically. This is done without doing any dismantling of the existing installation. We do not do any dismantling. That's why we do not call it retrofit. We only replace the gas with the eco gas version, we change the density monitors, we change the adsorber, and we change the filling valve. And that's it. So this is done in the existing substation. For any portfolio, there are a lot of new R&D investments are coming up, where the focus is on the new products, how the new products have less carbon emission. But our retrofill portfolio is for the existing installation, where the existing installation, without going into a write-off cost, can be upgraded, and the SF6 quantity can be reduced to minimum from the passive components. If you see, our retrofill mixture will have a composition of C4FN, which is a fluoronitrile gas, along with the nitrogen and the oxygen. So this composition, I can mention that we use 10% of fluoronitrile along with 85% of nitrogen and 5% of oxygen. Nitrogen and oxygen, by virtue of their property, they are natural gas, so there is nothing to worry. And this mixture has sufficient capabilities which are comparable to the SF6 gas. This also provides the opportunity to reduce the emission of SF6 gas, which is currently happening due to the leakage during the maintenance, troubleshooting, or INC of the GIS. This is a fast and effective process, as we are not dismantling anything in the existing equipment. Further, if I mention about the R&D which has been put behind this eco-gas mixture, it has been already duly type tested. We already have a qualified type test in terms of dielectric strength, in terms of current test, in terms of low and high ambient temperature. We already have it. And this is also qualified for, not only for this, if you go back to our proposed roadmap, we are also coming up with a 550 kV voltage level. So this is scalable also. Going more into this, how we are doing it, this is a retrofill procedure which we have mentioned in the snapshot, where we are reclaiming the existing SF6 gas from the existing bus duct. Then we are replacing the density monitors, gas filling valve, and the adsorbers, which are suitable for the new gas mixture. We are mixing all the three gases at site through a dedicated gas handling cart, and the new gas is simply filled into the bus duct. Now, when we talk about the gas filling valve, these are the special gas filling valves which have a QR code, so that to avoid any type of wrong gas proportion in the future. If you see, we have just shown the comparison between the SF6 gas and the new gas eco-gas mixture, where none of the functionality has been compromised. If you see the voltage level, short circuit ratings, current ratings, all are similar. So there is no difference between the SF6 or the eco-gas performance. This is how where we are presenting what we have in SF6 gas and what we are changing. So the first gas filling point is being changed with a new gas filling point which has a QR code, where the machine will be automatically sensing it and mixing all the three gases into the required proportion and filling it. We are changing the adsorber, which is basically to absorb the moisture and the other things from the compartment. The new adsorber will be suitable for the eco-gas mixture. The pressure remains the same. There is a very slight change in the pressure, so there is no difference in the pressure. And that is how the existing pressure vessels are also used without replacing them. We have the monitoring system available for this with new gas mixture also. Our current type tested solution is with silicon bushings. Important to note that in any GIS, we have O-rings, which are basically a type of a rubber and are put at the point of the interface of two of the modules. So there is always a possibility that with the concentration of the new gas, some of the components may get permeated through these O-rings. So this is also now tested with us, and our new eco-gas mixture, there is no permeation through the existing material. So we are not changing the existing O-rings. The gas levels are updated, and there is no increase in the terms of the weight of the solution. This is how we are showing that what we are doing, and for all these type of equipments, whether it's a specialized density monitor, analyzer kit, leakage detector, we already have vendors who are supplying to us, including DLO, Air Liquid. So there is a full backup support also available in terms of the vendors and the sub OEMs also. Our idea with retrofill is to provide the value addition to our customers, because if I mention about India, we have approximate from Hitachi Energy itself for the 400 kV, we have more than 250 bays which are already installed. And even in one bay of a typical 100-meter bus duct, I would say, there is a proportion of SF6 equivalent to 750 kg. So we are talking about a potential of removal of SF6 gas, 750 kg into 250 GIS bays, or maybe little less. So this is a high proportion, and this solution can actually contribute to the government's initiatives, customer initiatives on the reduction of carbon emissions. On the use case, we developed this in 2021, and we have already executed in 2021, and it was in 2022 it was commercialized. We have already done the retrofill for one of the GIS bays of National Grid UK, where we removed approximately 750 kg of gas from one GIL. This was for one of the bay, and further we are in discussion with client. So where here you see the green section is the portion of the GIL where the SF6 gas was removed. All the other section which is in yellow, it is still with SF6 gas, but the quantity of SF6 gas in the yellow section is very less compared to the GIL. So major 50 or 70% of the gas is in GIL. So this is already commercialized with the National Grid UK. These are some references of the pictures from our site at UK, where our Hitachi Energy team did this job. I don't know if time permits. I had a small video, if chair allows, for 2 minutes. No.
Quickly. Technology is good.
Okay. Okay. I will just take it quickly.
Involved in this world-leading project with Hitachi Energy. The project is basically to demonstrate that we can take SF6 from existing equipment, from gas-insulated bus bars, and replace that SF6 with an alternative gas with a much lower global warming potential.
The discussion I had with Adrian and the team in Zurich was, wouldn't it be great if you could just suck out the SF6 from these assets and put a different non-SF6 solution in?
It is groundbreaking, it's the world first, and it really potentially is going to have a significant impact on the industry, because we have a solution here which offers an alternative to SF6 on equipment which is already installed, which was designed to operate with SF6, and without changing the hardware we can exchange the gas and remove the risk of SF6 being released into the atmosphere.
And it will start a trend to move away from SF6 gas, which is obviously harmful to the environment, and the new gas will be a direct replacement which will allow us to benefit not only ourselves but also the environment, and hopefully will be the start of the future for us.
The road ahead for Hitachi Energy and National Grid looks like a repetition of this trial throughout the rest of the applicable ELK3 420 fleet within the UK on the National Grid network.
Our carbon emissions are dominated by the impact of SF6. So to be able to work on SF6, manage our emissions down, is absolutely key to what we're trying to achieve. In terms of meeting net zero targets, we have made a commitment to reduce our SF6 emissions to the environment by 50% by 2030. We've also set ourselves the ambition of completely removing SF6 from our operations by 2050.
So National Grid has a target to remove the SF6 from complete the network by 2050. Coming to my last slide of key takeaway, we have a lot of opportunities to remove SF6 from the existing network and also reduce the carbon emission. And in Indian perspective, if you see the government of India's perspective, it mentions regarding the long-term strategy for development of low carbon electricity system and carbon dioxide removal related engineering. From a user point of view, this type of solution can provide their ready-made solution for their Go Green initiatives and also for their organizational reduction for emission intensity. From legislation perspective, from this year, SEBI has mandated the top 1,000 listed companies to furnish BRSR report as part of annual report, which also includes the disclosure of greenhouse gas emissions and projects for reduction of the same. We feel that in future, this has the potential for providing the ESG-based lending and green credit programs which incentivize the environmental actions. So that's all from my side. Thank you. If you have any questions.
What is BRSR report?
It's basically a biannual report which is now submitted as part of annual report.
And now, what is the expansion for?
It mentions regarding the basic frame reporting for sustainability report, something like framework.
Okay.
Yes.
Thank you very much. Okay, one time.
Yeah, so we all know the importance of SF6 as per switchgear is concerned, and the voltage levels beyond which we normally opt for SF6. The question is inquisitive in terms of understanding the property of SF6, which is that's an electronegative gas.
Yes.
And that's why it has affinity towards electrons. It helps in quenching of the arc which happens in the switchgear.
Yes.
That's why I just want to know from you that the alternative gas, which is absolutely eco-friendly, what is your observation related to the arc quenching property of that?
So the arc quenching capabilities are same and comparable. In no way it is less than that. The only why the mixture of N2 and O2 is provided. In terms of properties, fluoronitrile and SF6 have the same properties. But why N2 and O2 are provided? To just manage the dew point and provide the conductivity. Otherwise, it is also electronegative gas mixture.
Thank you. And only one more point. We know the GWP value for SF6, which is around 20,000 plus.
25,000, close to 25,000.
22,800 around that. So now over here, having this alternative gas, what is the GWP value? It is less.
It will be less than 1,000.
Oh,
yes.
That's very good.
For the eco gas mixture, it is less than 1,000.
Good. Thank you.
Yeah, it's a quite interesting topic. The reason is that the utilities in India, the handling SF6 gas is very important thing, and nobody is following. To our knowledge, they are not following anything. So it is most important area of things. The replacing SF6 gas by other type of thing. So quite interesting. In fact, we recommended your paper. Very nice. And what about the patent and also Singh would have done it for this particular process?
So eco gas mixture does not have a patent. The fluoronitrile mixture was basically prepared by 3M. They had a patent, but now it is available for public use. And many of the vendors, OEMs like us, they are using that fluoronitrile and making it suitable. Many of the vendors like OEM are using this fluoronitrile and adding some more mixture like nitrogen, O2 in different proportion to meet the demand of the performance range of that equipment. But fluoronitrile was 3M, that was called as Novak gas, that was patented by 3M.
No, because you are giving the chemical formula itself.
Yeah.
So I just, but process also you can patent it. What is that? I am not able to understand. A company like commercial things, they don't do any company, they don't do any charity like that. So you are divulging everything. So what is the reason behind it?
So basically, since we are not a gas manufacturer in general as a company, we cannot have the patent on the gas. We can have patent on the equipment, because we are manufacturing GIS, and we are taking the fluoronitrile from the gas vendors.
Okay.
It's a source who will have a patent, the source who is, they are sourcing that gas from some other vendor.
That is true. But the process can be by mixing that.
So it does not come under our view. We have to use it. Fluoronitrile is a synthetic molecule. Since it's a synthetic, it's a artificial made. And who made it, like 3M made it, so they had a patent on the gas. But we are not using alone fluoronitrile. We are making it suitable for our process. So our GIS and the patented Econic product will be patented, not a gas.
Got it. Thank you very much. Interesting.
Excuse me, sir. I have a question, please. So, are we using this retrofill technology for other compartments also, like circuit breaker, isolator, CTPT of GIS?
As of now, this is for passive components, that is bus duct only, but we are working on it.
Okay.
Yes.
Thank you, sir.
Thank you. Thank you.
Thank you very much. Wonderful.
Thank you, Ankit, for your presentation. It was a really new and insightful technology and presentation, and your paper that you have submitted also, that was really good. So I would like to call upon the stage Mr. Gufran Basit from Siemens, because since he has a flight to catch, I would request our chair, Mr. Murugesan, to kindly hand over the memento of thanks to Mr. Gufran. And also Mr. Dalip Singhal from Tata Power Company. Please come over to the stage, sir. Would also like to invite Mr. Sairam for memento of thanks for the presentation for smart grids and for smart grids for smart cities theme that was there. His paper was like, definitely. So Ms. Lopa and Mr. Surya, please come over to the stage. They are the co-authors. They have written the paper along with Mr. Sairam Kumar. So the same hard work has been gone to this paper. Thank you so much, guys, for your submitting your paper and the presentation. Come on, guys. Thank you. Thank you. Now I would like to invite Ms. Aarti V, R&D engineer from Hitachi Energy. Her paper is Field Data Evaluation for Lines Connected with Renewable Sources. And Ms. Aarti V has done a BTech in Electrical and Electronics Engineering from NIT Tiruchirappalli in 2021. And she also has a degree in Smart Electric Grid from National Institute of Technology, NIT Warangal, India. So without any further ado, I would like to hand over the stage to Ms. Aarti.
I took one course on smart grid. Yeah, good. For NIT Warangal.
Okay. Please. So good evening, everyone. I'm Aarti. So my topic for today is field data evaluation for lines connected with renewable sources, way forward. So my co-author is Dr. Odi Naidu from Hitachi Energy. So let's move in. So these are the contents of my slide. So let's dive into the introduction. So the energy demand is increasing rapidly. So as we move towards greener energy, more integration of renewable energy is taking place worldwide. So by 2030, it is anticipated that the renewable energy integration will go to 500 megawatt or even sooner, as quoted by the additional secretary of the MNRE. So this large integration of renewable sources comes with its own challenges. So the major challenge here is that the characteristics of power system is no longer governed by the laws of synchronous generator, but is governed by the converter controls through which these renewable sources are integrated with. So today we are going to see the challenges of these converter controls and how these impact the existing power system protection schemes, and how do we overcome these challenges. So now, coming to the relevance part, so our target is large integration of renewables to overcome climate change, to reduce carbon footprints, etc. So for that, we need a reliable and secure power system protection. Now, in order to design a reliable power system protection, we need to understand what are the challenges with the existing protection schemes for renewable sources. So today, our focus is on the challenges part. So first, let's understand what are the challenges of overcurrent relay for IBR connected systems. So as we know, these wind farms or solar or any renewable energy is integrated to inverters. So due to this converter controls, which are basically power electronic devices, so in order to protect these power electronic devices, the fault current or the current through the devices are limited. So because of this, there is mal-operation that can happen in the overcurrent relay. So let us understand this with an example. So here there are the current waveforms for a field data obtained from a wind farm connected system in the western part of India. So this system configuration looks as shown in the right hand side of the slide. So here the wind relay at the wind farm end waveforms looks as shown here. So here we can see that this is a BG fault. So for a BG fault, here we can see both A phase and B phase currents have raised, and it has raised from the pre-fault current of 200 amperes to 400 amperes, which is 2 times the increase. Whereas in case of grid end, we can see that for a BG fault, only B phase currents has raised, and it has raised from 200 ampere to 10,000 amperes, which is a vast increase. So when we compute, when we plot this phase B current in terms of per unit, and if you compute the plug setting, multiplier setting, we can see that for the wind farm end, it comes out to be around 0.88, whereas in case of grid end, it comes out to be around 12.5. So it is expected for the PSM to be greater than 1 for the overcurrent relay to operate. So in this case, we can clearly see for the wind farm end, the overcurrent relay might not operate. So this is one of the challenge. So next, let us see for the distance relay perspective. So because of these converter control scheme, there is abnormal angle shifts in the voltage and current signals. The source impedance of this renewable sources is varying constantly, since IBR being the weak source. And also the reactive current generation criteria is dictated by the grid codes with which these are modeled, and also these PWM controls tries to balance even if there is a disturbance, which causes balanced current even during asymmetrical faults. So let us understand how these challenges impact different modules in the distance relay. So let's first understand the fault classification output. So here there are plots of the delta V plus, which is the superimposed positive sequence voltage angle, and the delta V naught, which is the superimposed zero sequence voltage angle. So here we can see that for the grid end, this being the BG fault, the delta V plus settles nicely in between minus 120 to minus 150 degrees, and the delta V naught again settles in 120 to 150 degrees as expected. But in case of IBR end, we can see that the delta V plus fluctuates after almost 1 cycle after fault, and also the delta V naught does not even settle in the desired zone. So in case of grid end, the fault is identified as BG fault, whereas in case of IBR end, the fault is identified as AB fault. So this might lead to confusion in the distance relay. Also, similarly, because of this abnormal angle shifts in voltage and current, the fault direction output is also affected. So if we see for the same example, in case of grid end, the fault is correctly identified as forward fault in case of grid end, whereas in case of wind farm end, we can see that the directional index is fluctuating throughout, leading to no proper output from this fault direction module. Now, let's understand the distance part. So here, to understand this, let's consider an example of a BC fault at 60% of the line with RF 20 ohms. So here we can see that the apparent impedance traditionally can be calculated at VB minus VC by IB minus IC, which can be broken down into ZF plus RF into 1 plus the remote current part by the local current part. So here when we calculate the impedance, it comes out to be around 39.27 plus 41.16i. So here we can see the imaginary part is almost close to the expected value, which is 30.46, and the distance, the trajectory enters the zone 1 and the operation is as expected, and also the current angles between the remote end and the local end is around 8 degrees, which is considerably smaller. But in case of the wind type 4 generation, we can see that the ZBC that is computed comes out to be minus 8.22, which is the imaginary part. So the impedance comes out to be negative. Hence, this trajectory does not enter the zone 1 part, and also the angle between the remote current and the local current comes out to be 60 degrees, which is very high. So if we term this angle of local current and the remote current and the local current as alpha, so this alpha can be negative or positive based on the grid codes with which it's modeled. And so based on this alpha, there is this delta Z, which is the deviated component, which has to be compensated if we want to design a reliable distance relay. So for the same example quoted previously, if we see the distance trajectory plots, So here we can see for the there is a fault with from 5% of the grid end. So in case of grid end, the trajectory enters inside zone 1 and settles nicely. But in case of wind farm end, it is supposed to enter in the zone 2 region, but it settles outside, which leads to mal-operation of distance relay for this case. So now let us see for the differential relay. So because of this non-homogeneity factor, so we have considered an example of AB fault at 1.5 kilometer for a wind farm connected system. So when we consider only linear characteristics or a constant threshold, so here we can see for AB fault, none of the phases, which is ABC, has crossed the threshold. So this is not the expected output. But in case of dual slope characteristics, which is a combination of linear slope and the dual slope characteristics, the expected output is obtained. So for the field data seen previously, here we can see the B phase nicely settles in the operating region, and hence this proves that in case of IBR connected systems, the differential relay, if incorporated with both dual slope and linear slope characteristics, is reliable for IBR connected systems. The same is tested with almost 4,000 simulated data and also with this field data, and it is found to be reliable in this case. So the key takeaways for today's presentation is, so due to the converter controls in IBR connected system, the fault current is modulated, the voltage and angles, current angles are affected. So due to this, the existing protection schemes such as overcurrent relay and distance relay are affected. But in case of line differential protection, if the line differential protection, the K factor is modeled in terms of both dual slope and linear slope characteristics, it is reliable for IBR connected systems. These are the references. I thank ISGF for providing me this opportunity.
Actually, I took one semester course, one subject on smart grid system for NIT Warangal. She is one of the students. Thank you very much. Wonderful.
Thank you, Aarti, for the presentation. Now, swiftly moving ahead, I would like to invite Mr. Chunendra Kumar Singh Chaudhary, representing IIT Roorkee. He's a PhD scholar at the Department of Hydro and Renewable Energy at IIT Roorkee, and he has worked on this paper under the guidance of Professor Rhythm. So, without any further ado, let me invite him to the stage. Oh, my timer is going on. Yes.
A very good evening to all of you. My name is Chunendra Kumar Singh Chaudhary. I am a PhD scholar at IIT Roorkee. I am working under the supervision of Professor Rhythm Singh. Today I am presenting my work on an overview of the challenges in reaching the 2030 solar PV target in India. Beginning with the introduction, in every technological or non-technological aspect, policies plays a crucial role in achieving the targets of that thing. For the case of solar photovoltaic in the Indian scenario, JNNSM has positively affected the growth of solar PV in the country. JNNSM has implemented in the year 2010, that has been updated in 2015, also called as National Solar Mission. So the implementation of National Solar Mission has positively affected the solar PV installed capacity, and as we can see from the graph, the blue trend shows the graph of historical installed capacity till now. It is exponentially rising. And the capacity of solar photovoltaic till now we reached is 74.31 gigawatt, contributes to 17.28% of total installed capacity and 40.81% of among all renewable based sources. In achieving this target, the target that has been proposed with National Solar Mission in 2015, that is India set a target of achieving 100 gigawatt by 2022. For that target, country achieved 63.30 gigawatt of installed capacity, constitutes to achievement of 63.30% of proposed target. In achieving this target, our country has faced so many barriers and overcome those barriers also. These historical barriers are classified into 5 major categories: technological barriers, economical barriers, environmental barriers, social barriers, and auxiliary barriers. In the technological barriers, the barriers are low conversion efficiency of solar PV panels, intermittent nature of solar photovoltaics, operation in high temperature leading to component failure in the PV system, and in economical barriers, high investment cost that also exist in the current situation. In the environmental barriers, emissions in the manufacturing process, recycling of e-waste is a challenge for in solar PV. For social barriers, the lack of social awareness in the consumer end is a major barrier. For the auxiliary barrier, dust deposition and cleaning is the challenge associated in solar PV. So for the current study, the relevance is about the future target of our country. So the future targets of our country are 500 gigawatt of renewable energy by 2030, consisting of 280 gigawatt from solar photovoltaic, and net zero target by 2070. In achieving this target, we have to discuss the challenges we are facing in the current situation so that we can achieve our target by 100%. So these challenges are majorly associated with the stakeholders of solar PV that make a supply chain of the solar photovoltaic. These stakeholders of solar PV consist from the manufacturing to the consumer end, named as solar PV manufacturers, suppliers, consumers that are residential or commercial and industrial, government and regulatory bodies for the role of policy, regulation, incentives, etc., grid operators, discoms, operation and maintenance providers, R&D agencies, insurance providers, environmental agencies, certification and standard bodies, EPC contractors, investors and financiers, and project developers. So I will discuss the challenges associated with each stakeholder in the upcoming slides, beginning with the challenges associated with government and regulatory bodies. So for the case of rooftop, government and regulatory bodies has implemented good sustainable models, that is also known as renewable energy service company models and capex model. But still there is more need of implementing such models to increase the growth of solar rooftop in the country. So for the RESCO model, I have studied a case study that has been done in the IIT Roorkee. In IIT Roorkee, Tata Power has installed 1 megawatt of PV system under the RESCO model. So for 1 megawatt, the space required is 6,000 meters square, and the tariff rate of that PV system is rupees 1.899 per unit, and the term of that PV system is for 25 years fixed tariff, and the current tariff from the grid we are if we are consuming the electricity is rupees 5.4 per unit. So according to the grid and the energy we are consuming from PV system, the saving per unit is rupees 3.51, and 1 megawatt of solar produces 14 lakh units annually. So annual savings in electricity will be rupees 49.14 lakh. And additional savings are the reduction in peak demand that will be in positive fund for the grid. The second, yeah, yes sir. Okay, so you are talking about the capital cost of the solar photovoltaic. So I will tell you. So the current capital cost of solar photovoltaic in the country is $640 per kilowatt. So according to that, for 1 megawatt, it is multiplied by the 1,000. So it's almost 6,40,000 $US per megawatt. Yeah, yes sir.
For 5 crore, you get only 49 lakhs.
No sir, it's annual savings we are getting. It's as comparison to if we consume energy from electric grid.
How much energy you generate?
14 lakh units annually from 1 megawatt plant. Yeah. Then the second challenge government and regulatory bodies are facing in concern in acquiring suitable land for solar PV projects to support development of large scale PV projects. That has been an historical challenge also and the current challenge also. Then the financial resources for implementing the large scale PV system and the rooftop PV system. And the fourth one that has not been studied yet by most of the industries and academicians. That is the tackling the recycling of PV panel waste after its end of life will be an issue for government and regulatory bodies. Now the challenges associated with solar PV developers. With the developers and manufacturers, there is lack of effective communication between both of them. As the developers are mentioning that there is a lack of supply from the manufacturing side, and while manufacturing is similarly saying there is lack of demand from the developer side. And similarly, second challenge will be the monitoring and management of the PV system in the ground. Third one is challenges due to the ever-changing market condition and the unpredictable nature of solar power demand. And the fourth one is associated with government and regulatory bodies also, that is delays in acquiring the required permits and approvals can result in significant project delays. And the imposition of custom duties also affect the solar PV developers is like the custom duties, basic custom duty that has been implemented for solar PV panels, implemented in 2022. So you have to pay 40% extra for the imported solar PV panel from the international PV manufacturers. For the challenges associated for the solar PV manufacturers, the manufacturers are constantly facing the challenge of reducing production cost due to intense price competition with the international manufactured PV panels. As international manufactured PV panels are less cheaper, so everyone want to buy that PV panel. So domestic PV manufacturers are facing that challenge. And the ever-changing nature of solar PV technologies as new solar cells are coming out. So this challenge is also an opportunity for the PV manufacturers and a challenge in updating this PV panels. And the third one is the shortage of skilled workers in solar manufacturing with an underdeveloped supply chain as to the complexity of the situation. The fourth one, factors such as global supply chain disruptions, geopolitical events, and the ongoing COVID-19 pandemic introduce uncertainties that affect the availability and cost of raw materials. I want to put this point on this graph. The orange trend is showing the capital cost of solar photovoltaic in the country. As you can see, after the 2021, the capital cost of solar PV has rise from 592 to 640 $US per kilowatt. So this is due to the COVID-19 pandemic came in the country. So these events and these pandemics affect the cost of the capital cost and also affect the stakeholders and make their challenges more. So according to the research of Institute for Energy Economics and Financial Analysis, the module manufacturing in India has now reached to 38 gigawatt, and solar cell manufacturing in India has now reached to 6.6 gigawatt. And they are projected that the module manufacturing by 2026 will reach to 1110 gigawatt, and cell manufacturing will reach to 59 gigawatt. So for achieving these targets, there are need to overcome these challenges that I have discussed. Now, for the DISCOMs, the major challenge is about the consumer dynamics. So, for the DISCOMs, there are two types of consumers. One is the residential, and the second one are the commercial or industrial. So, for DISCOMs, commercial and industrial consumers are the high revenue generating consumers as compared to the residential consumers. If solar rooftop implementation for commercial and residential consumers are there, then the revenue generated for DISCOMs will become less. So that will be a challenge for distribution companies. Then the other one is channelization of private investment in the distribution sector for state-owned DISCOM is a challenge. And as I said about the solar PV rooftop, DISCOMs perceive solar PV rooftop as a challenge leading to revenue loss and financial implications. And the implementation of solar PV system in the grid or the rooftop, DISCOMs would need to upgrade DSOs, and implementation of virtual power plants will be necessary. Integrating small-scale distributed solar installations presents additional challenges for DISCOMs as they navigate the changing landscape of renewable energy adoption in the market. Now the two stakeholders that are remaining are grid operators and the solar PV consumers. For the grid operator, the main challenge is the stability of the grid. They have to maintain the grid stability in terms of voltage stability, output power prediction, frequency response, and reactive power support. Large-scale solar projects may also necessitate transmission and distribution upgrades to ensure optimal power flow and reliability. Also, it is crucial for grid operators to engage in accurate long-term planning and capacity expansion to accommodate the increasing solar PV capacity. In protecting PV system from various faults, conventional fault devices need to be updated to the need to be updated. And the final one is, it is essential to develop strategies that address grid resilience and security challenges such as cyber threats and extreme weather events to ensure a strong and a dependable energy infrastructure. So, for the conclusion of grid operator, the main thing is to maintain the grid stability, and there is need to upgrade the transmission and distribution devices that we are using. So, challenges associated with solar PV consumers, the one is that is historical also, and the current challenge also. That is the high initial cost of solar PV system to implement it at home. So that might stop people, especially those who lives in home, from using solar energy. And the second one is the maintenance and the operation of the PV system at home. And the third one, the lack of awareness in the consumer. So they have not much information of solar energy and the advantage of solar energy. So it is crucial to educate consumers about the environmental, financial, and energy security benefits of solar photovoltaic. So from this study, the final conclusions and recommendations from mine is, one is the policy uncertainties, land acquisition, supply-demand imbalances, and concerns about grid stability are some major challenges hindering the solar PV growth in the country. So it is crucial to adopt a collaborative approach between the multiple stakeholders of solar photovoltaic for effectively addressing challenges in a comprehensive manner. It is crucial to prioritize the development of expertise in the solar industry to tackle the issue of a lack of experienced workers, specifically in the solar PV manufacturing side. Or it is crucial for policymakers to suggest and execute robust policies and regulatory frameworks that cover the entire manufacturing supply chain to enhance domestic manufacturing. For domestic manufacturing, available options are to provide low interest rates, free land, and reduced electricity tariffs to support domestic manufacturing. PLI is also a good scheme, as after PLIS came in 2020, as I discussed, the growth of PV domestic manufacturing in the country. After 2020, it has been rise, and now it is reached to 38 gigawatt till now. And the other one is the trade policies. It is crucial to consider trade policies, technological advancements, and domestic support mechanism to promote a strong and competitive solar PV manufacturing industry in India. And for the grid operators, investment in advancing grid management technology is crucial to ensure a stable and reliable power supply. Also, for the solar PV intermittent nature, the hybrid solutions are the one that need to be preferred. Either solar with the battery energy storage or solar with the other renewable energy based sources. And for the solar and wind hybrid power plants, there is so many work going on. These are my references I have taken for my study, and thank you. Please feel free to ask if you have any questions.
Thank you very much. Maybe that, actually to make it happen, government role is very important. Yeah. So you need to maybe work on why, you have a target. Yeah. So to reach the target, you should facilitate things to happen, whether it is a manufacturing or tariff or such things. But all are a little bit silent on the part of the stakeholder government. And that means next paper, without any hesitation, you need to work on that. Because unless otherwise that is done, all are will be in theory only, will be struggling. When we say the 100 gigawatts,
280 gigawatt by 30.
We have reached only 62.3% with all halabala talking. So it is very easy to do that. But the primary is government, which has to facilitate. You see, like in the US, they give lots of incentives to introduce a technology or anything like that. Tax holiday, that, so many things. So it is coming up. But kindly work on that.
Okay, sure.
Thank you very much.
Thank you, everyone.
Thank you, Chunendra, for the presentation. Now, moving ahead with our next presentation, I would like to invite Mr. Raghuveer Singh from Tata Power Delhi Distribution Limited for his paper on revolutionizing last mile delivery. So, without any further ado, we'll start with the presentation. Over to you, sir.
Good evening, everyone. First of all, I would like to thank ISGF. First of all, I would like to thank ISGF for giving me the opportunity to present my technical paper. So my technical paper is based on revolutionizing last mile delivery, the power of automation for enhanced reliability and customer satisfaction. Basically, I have been associated with Tata Power DDL, which is a distribution utility. So this is a general overview of my organization, that we have 85 grid substations and number of transformers are 216, and we have peak demand of 2228, and we have consumer base of 20.40 lakhs. So, being in a distribution business, one of our core focus is to provide the reliable power to the consumer. So, for that we have adopted many technologies in the organization. Since we got the license of this distribution of electricity in this north and northwest part of the Delhi. So earlier we were at the value of technical loss of 53%, and our grid substation were totally unmanned. As we continued our journey, we have upgraded our grids as communicable. It is totally unmanned, and we implemented SCADA ADMS, Advanced Distribution Management System, outage management system in the organization to automate these grid substation and manage the consumers. So the base application that we are currently using is Advanced Distribution Management System, and one of the modules that we are using for this is SCADA, and some new technologies that we call DPF and APRS are also added on this. We call it distribution power flow and automatic power restoration system. As I have already discussed that our grid substation are totally unmanned. It is using this SCADA to operate the device from a control center, and down the line is also some devices are automated through distribution automation. But being in a discom business, it is not feasible to automate all the equipments. So what we do that we have an application called ADMS. So we have another modules, another advanced modules of this application that enable us to using this SCADA data at some level and using it down the line for restoring the fault. Basically, I'll give an overview about DPF, distribution power flow. What it does, that we have a SCADA values at some particular level, at grid level, at 11 kV grid breakers. So we can use that data. Along with that, we have the customer data as well. Like we have data of our DT, how much sanction load are connected to particular DTs in our distribution areas. And by merging those data, we are taking GIS as a reference for collecting data like the types of cable, whether it is underground or overhead, or what is the impedance on those cables. And this system gives us the overall how much load can be running on these DTs or these consumers without having SCADA devices connected to them. So based on this, at a higher level, this SCADA value, and in lower level, based on the consumer segments, this the module of distribution power flow give us the data. And the another application that we use is automated power restoration system. What it does, that it takes this automated data from the SCADA and use the load data that we from DPF, and collectively using those data, it give us a it gives whether it gives us a switching option as well. It give us a it operate the device to restore the faults. Some basic feature of automatic power restoration system is it uses the telemetry data, like the data that we receive is the indication value from fault passes indication. Along with that, it uses the breaker status at grid level, and it use these data to give us whether as a switching suggestion and restore the fault by automatically without any manual intervention of operators. And along with that, it can even there are no consumer connected to a particular section, but load is but there is a de-energized section is getting created. It also restore the fault at that level as well. And distribution power flow basically allow state estimation studies to be carried out. So instead, load flow study are used as basis for fault level studies. It doesn't only give us for switching operation data for switching operation. It can be used for our data analysis part as well. And the DPF in ATMS can consider as I already mentioned, that it can use the real-time measurement as well as load profile data available at the load point, and can distribute the load current accordingly. And these DPF is also the base application of this APRS. We have also the module called integrated wall-to-wall control. We have a group telecontrol module as well that we can use for the DPF is the base application for these. This is just an overview of how a fully SCADA substation, how it is visible in our system. At this particular level, we are operating fully by sitting in a control center without sending any particular man workforce over the field. Just a brief explanation how this APRS is restoring the fault. Suppose as you can see that there is a fault is given in the given here. If a fault is created over here and FPI glows upstream of this level, so the APRS will automatically take decision that if this fault has taken downstream of this network, so what it will does, it will restore the it will operate a device, restore that isolate that section, and also the next switching station, it will also create a switching sequence in downstream, and by n-1 procedure it will restore the rest of the fault. And if you can see that just this section will now be isolated, and by closing breaker at this section and at this section, the complete load will be reduced. You can restore the 70 to 80% load by backfitting within a 5 or 10 minutes of interruption without any manual interruption, based on this FPI data available at the our advanced distribution management system coming from field. So your 80 to 90% load can be restored within a 5 minutes, or sometimes less than a 2 or 3 minutes. Yeah, thank you.
Thank you very much. Actually, the Tata Power is doing great job. In the sense, it has become a benchmark for rest of the utility. It's not to boast or anything like that. Do you know that what is that transformer failure in other utilities? Any idea? Distribution transformer failure rate in terms of percentage. Normally, it is somewhere around hovering around 6 to 8%. But in Tata Power, it is 0.75%. So extreme, because of the automation, they kept the failure rate monitoring, transformer monitoring and all such things. This is an international benchmark. It is not that national, international benchmark they are reaching. And in terms of another thing is that one is the transformer failure, another. And what is that total loss also you have brought on. You have done many other things you have exceeded. Done it. And what is that interruption per customer? In terms of, say, sometime in terms of hours, in terms of minutes, how much you have achieved? Anything figures you have? See, normally, example, take a city like Tokyo. Tokyo Electric Power Supply Company, the TEPCO, it says that automating their network, and average customer see the interruption per annum is only 4 minutes. Just 4 minutes. The customer may see or customer may not see that 4 minutes. But the utility says that it is only 4 minutes. You can see that what is the availability in terms of 99.39 or 59, you can do that. So do you have any statistics on that for Tata Power?
It is around 14 minutes. If we are talking about study, it is around 14 minutes. 14 minutes, sir. 14, 1 4.
No, it will be higher. No, average interruption per customer per annum. You should have that because you are automating the things. So after automating the thing, how much you reduce the interruption duration?
Actually,
say for a typical utility, you will have somewhere around 90 hours after introducing the automation systems.
Actually, sir, as we are just in the beginning of this implementation of this APRS and DPF, so what we are doing is we are mentioning that how which type of which particular interruption we have restored by this application.
That
so we will definitely compare that how we have reduced the SADI and SAFI in coming years as well.
Ultimately, you want to make available power supply 24/7.
Yes,
that is our objective.
Definitely.
So, to what extent you automate it and bring the time interval, and just I want to know that what is the time per annum with existing automation system, how much the customer is denied of power supply. Certainly, it is not 100%. It is not possible for any utility, but relative time. But they are doing extremely good work in India. So I always take Tata Power statistics. 16 hours, na? This is a good number. See, for city like Bangalore, Karnataka, where they have introduced this distribution automation systems. There is 11,000 feeders, 11,000 feeders, 11K feeders. The average interruption is somewhere around 80 hours. With introduction of automation, still 80 hours. 16 hours is a reasonably wonderful figure. Wonderful figure. Thank you very much.
Thank you, sir.
Thank you so much, sir, for the presentation. Would like to now swiftly move on to our next presentation, second last presentation of the day, which is by Mr. Abhinav Mogha, HOG Grid Automation, ADMS and OT Cybersecurity, Tata Power Delhi Distribution Limited. Mr. Mogha has over 15 years of expertise in utility automation, process automation, project management, and engineering. And he has also played a pivotal role in the operation and maintenance of grid substations and process automation systems. As a core team member, he has contributed significantly to the implementation and commissioning of ADMS and grid substation automation. So, without any further ado, let's invite Mr. Abhinav Moga for the presentation.
Good evening, everyone. First of all, I would like to thank ISGF for selecting our paper and having us here for the presentation delivery. So my project title is ABT meters installation for efficient energy accounting and real-time power forecasting. During the implementation of this project, our main objectives were accurate energy accounting and efficient power forecasting so as to ensure reliable electricity supply and demand management in modern power systems. Under this project scope, our target was to install 197 numbers of ABT meters in total exchange points, DTL exchange points, and also to establish a dual network communication infrastructure so as to ensure the data reporting of these ABT meters at energy audit group servers also, and also parallelly to ADMS system also for power forecasting needs. With the implementation features, yes, of course, efficient load forecasting by utilizing the class 0.2s class data of ABT energy meters for power scheduling purposes. Availability based tariff, as the ABT meters offer the 5 minutes data integration of active power and reactive power values. So especially in the case of time of use scenario, billing scenario, to enhance the billing efficiency. Energy data digitization, of course, because these days we are like oftenly talking about the transition of energy values to information value. So we had to establish a rugged communication network for parallel reporting of data to energy audit servers also and our SCADA systems. Background of the project, like we were facing few challenges with respect to our existing technologies. Our existing interface energy meters were non-DLMS, so they were not compatible with the DLMS protocol. So we were having multiple OEM softwares, and we need to access those IEMs through those softwares, and we had to go to the sites and we have to do the manual reading of those meters. DSM penalty. So we have analyzed also like approximately 50% of DSM penalty. The reason behind was the data mismatch, the SCADA data mismatch error when we are comparing the SCADA data which was being used for the power scheduling and the DTL energy meters data. So we were having the discrepancies on those in that data, due to which our DSM penalty was getting hit, and it was roughly approximately 50% it was accounting. Time sync issues, because when you shift to the availability based tariff, or you can say the time of use billing scenario, you need to have the proper time synchronization in meters, which was not previously there. Meter failure, because when these IDs, more and more number of IDs are actually getting integrated in a power utility in different verticals of a power utility. So we need to have a proper diagnostic systems also in order to detect the failures of those IDs. So previously in those meters, we were not having that diagnostic features so that we will be able to detect the failures on real-time basis. So you can see the ADSM penalty graphs from year on year, like from FY17 to FY23. In FY23, we were having almost 10.2 ADSM hit, 10.2 crores. Due to the strict DSM regulations we are having, so the previous meters were not capable to provide real-time demand data. And also the high penalties, actually it's disturbing the financial health of the company, power utilities. When we carried out the analysis, we found that there is a discrepancy, several instances of discrepancies between the data, SCADA data and the meter data which we took from DTL. And that too, after that analysis we were doing, after 1 month, when we could actually get the data from DTL. That was not, we are doing in a real-time basis. So this histogram in the right below, you can see the histogram also depicts error distribution, in which we can see the errors surpassing plus minus 5 megawatt, which was the desired value, and it was close to the mean was 10.55 and the standard deviation was 10.94. So there was a urgent need to revamp this interface energy meters infrastructure so as to improve our energy accounting also and also minimize our DSM penalties. So through that, we took up the challenge to install 197 numbers of ABT meters with 5 minutes data integration, and also to have parallel reporting dual network, so that data can give, that meter can give data on DLMS also, and also on real-time utility protocols like Modbus RS485 to cater the issues of interoperability. So this was a project charter. It shows the RO placement was done in April in 2023, basically FY24. So meter delivery, we also did the demonstration or some kind of pilot testing to ensure the communication system should be in place when we actually go to the site. Then the second RO placement, then installation of complete 200 numbers of meters, integration with EAG servers and ADMS. In the right top, you can see this dual network. Previously, this was not there. So this is one of the ABT meter with one of the port which supports TCP DLMS protocol. It is giving data through Ethernet switch, through MPLS router to our EAG energy audit group servers. And on the left side, it is parallelly reporting data over power utility real-time protocols, which is RS485 Modbus. And we have utilized our existing RTU infrastructure to map these data points and to report all these data points through the well-secured protocol up to our master control center and backup control center, so that this data, the real-time data, can be utilized by our power manager team in order to have efficient real-time power scheduling, intraday also, before day also, and intraday also. Benefits of the project that we mentioned, accurate meter data with time synchronization. It is very pertinent to mention that when we will approach to the time of use billing scenario, then these ABT meters will play a crucial role, because you need to have a time synchronization on a real-time basis, which the previous meters were lagging. High accuracy 0.2s class data for power forecasting, because up till now most of the utilities are dependent on relays, BCPU, Bay Control and Protection Units, and the conventional multifunction meters, which are not supporting the 0.2s class data. and there is always a difference. So you need to always you need to have a trade-off between that data. So when you actually compare that data with the DTL meter data or whatever the exchange point meter data. So with the ABT meter, we are having this high accuracy 0.2s class data. It also helps in active reactive power management. To mention here, now with while utilizing this data, we are developing a auto logics in our RTU systems to switch off and switch on our cap banks, so that we will be able to mitigate our reactive power penalties, which is the next big thing after DSM penalty in a utility context. And also it contribute to the improved grid stability. So overall project cost is 4.06 crores. DSM penalty in FY23, 10 crores. And up till February, we able to minimize it to up to 2 crores. And after, in FY24, we are targeting 2.16 crores to close this figure. Yes. So this is basically our case study. We were having a problem, high ADSM penalty. Current level in FY23 was 10.2 crores. Desired level was 3 crores in FY24. So with the Pareto analysis, we came out with the SCARA data was contributing up to 30% of ADSM penalty. That analysis we did for April to July 23, FY23. Then there are histogram analysis, QC tools we have used to analyze the issue. Action we have taken to for the replacement of our interface energy meters. Then after results, 10 crores to 2 crores till February 24. And with the standardization perspective, previously it was not happening. Through this data and we are generating the real-time alerts in case of any meter is going offline. So we are having real-time alerts to the maintenance teams. So we are not relying on our customer that he would initiate this thing or escalate this thing as a non-compliance to maintenance teams. Instead, maintenance teams will be acting as in a proactive scenario. The major key takeaways is after the successful implementation of this project, we are collaborating with our IT team to have a robotic process automation of exchange data reports in which we are having real-time alerts, communication offline cases and deviations. It is on a real-time basis, it is comparing the SCARA data which we are getting now through ABT meters and the ICCP data, and on a real-time basis if any deviation occurs, it initiates a message, alerts, notifications or mail to the maintenance teams there is an issue you need to resolve as soon as possible, so that the power manager would be able to manage the power demand and supply efficiently. And we are having auto-generated reports as well for any abnormalities in data integrity. We are using QC tools also, like the histogram we used earlier, and also this data n-, because up till now we are only focusing on the network n-1, n-2, n-3. Now we are focusing on the data n-3 redundancy. So yeah, and for the power scheduling, the data for the power scheduling purpose which is being used. So the auto switchover mechanism we are using, the first priority is for the ABT meter, the second priority is for the BCPU and relay, the third priority is calculated ABT, and the fourth priority is the calculated BCPU. So these are few references. So thank you.
Thank you very much. Actually, the Tata Power is more than a distribution company doing lots of research. Every year we see plenty of papers. I don't think any utility is, doing this kind of things in India. We are proud of you. Thank you very much.
Thank you very much. Thank you.
Thank you, Mr. Muga, for your presentation. Now, moving forward with our final presentation, but definitely not the least Ms. Surekha Deshmukh, and the paper is on developing data-driven tool based on life cycle assessment for computing carbon footprint across electricity value chain. Ms. Surekha Deshmukh is domain consultant, IoT DE TCS Pune, and she is carrying over 25 years of professional experience. So it's an honor to have ma'am with us today, and I would request ma'am to kindly give us the presentation.
So very good evening to one and all. See, being the last speaker, sometimes you can take this liberty of summarizing what so far we have done in the day. And what a wonderful day. This day we spent together discussing about where is the trend of technology going to one common industry, that is utility industry, all of us we belong to. Yes, I'm an electrical engineer. I did my master's in power systems and my doctoral research in generation scheduling. My technical, problem statement was sponsored by State Load Dispatch Center. That was the era of inception of ABT. So I have worked with State Load Dispatch Center along with IEX, so as to develop an AI tool for predicting load, predicting frequency, predicting renewable generation, predicting price of power, and then take up a decision of how much of power should get generated by state, how much of power they should trade, how much of power they should get from market. That has become a kind of that was way back, almost that was a work I could say a decade before that I did as a part of my research program. Now coming back to the topic of today's session here is, though in the morning, till morning, all of us, we talk about digital interventions, we talk about data, we spoke about AI, we spoke about drone, computer vision, image analytics. We spend a lot of time talking about asset management. We talk a lot of time on the way you see technology growth penetrating in the entire electricity ecosystem. I found each and every author still touching to a very important aspect of sustainability, environmental impact. Words would be different. Words could be in terms of global warming potential. Words could have been in terms of GHG. Words could have been in terms of minimizing the emission, having some sort of a synergy towards environment, etc. But the takeaway is like this, that though we are transforming in terms of digitalization, as we all know about COP28, where the consensus of COP28 has come up with three primarily key focuses. One was tripling of renewable energy, second one was doubling of efficiency, energy efficiency, and then thoughtful transitioning away from fossil fuel. It means all these three aspects actually makes us feel that what is our responsibility as an electricity industry in terms of going ahead in energy transition, decarbonization, circular economy, and making this industry very much close to the environmental impact, minimizing the environmental hazards. And that's one of the reasons we thought of coming up with the point of view and a paper where we, as a TCSer, we consult with multiple utility industry across globe, and we help them in creating a roadmap for sustainability, looking at their transmission and distribution business portfolio on how they can quantify the presence of embodied carbon as well as variable carbon associated with all the assets under their umbrella, and where is the scope for decarbonization and where is the scope of enhancing biodiversity, etc. And for that matter, of course, we have to follow the industry tool. Here comes the industry tool, which is there in the title, that is life cycle assessment. So the couple of slides coming before, they talk of how life cycle assessment is a very well-known and a very strong industry tool applicable for utility industry also to compute emission impact, say global warming potential across the value chain of utility industry. So as per introduction of this particular theme is concerned, it is again very much aligned with the need of today, the way we are transitioning towards Industry 4.0, the way we are embracing towards technology. We really need to see the impact of technology on environment in terms of around 13 to 14 environmental categories, which starts with GHG emission, which starts with global warming potential. We need to know where are we and what is the impact of my business, my activity, my asset, and the commodity which is actually I'm generating, transmitting, distributing, and even consuming on human toxicity, etc. So knowing the fact that everyone has to go and has embarked on the journey of net zero, to be able to achieve net zero, each and every stakeholder has to contribute. So when we say each and every stakeholder, it means each and every industry is also having certain set targets. And now when we talk of set targets towards net zero, here we have certain regulatory compliances like GRI, SASB, TCFD, TNFD, and each and every industry, including utility industry, they do submit their targets to SBTi. Now the very good presentation that we have heard about the switchgear, Hitachi Energy getting into the switchgear transformation from going ahead away from conventional SF6 towards something like an eco gas filling into the switchgear is the best example of how we are adopting ourselves from industry perspective towards the need of sustainable industry transition. So we actually call this as a kind of a sustainable industry transition to 4.0. Now, when we speak about life cycle assessment, this is an industry tool which is very well popular for manufacturing industry, where it helps that industry to understand impact of material flow across its life cycle. And the same philosophy is applicable to utility industry to understand the carbon footprint and emission impact of each and every activity that we do. And the reason why it is very apt for electricity utility, and that's one of the reasons we do help multiple customers across globe, applying this life cycle assessment for computing their carbon footprint is mainly that unlike any other industry, our industry is distributed across thousands of miles. It consists of thousands of substations and thousands of assets. And that's one of the reasons to be able to be accountable for carbon footprint, we really need to know the distributed nature of presence of embodied carbon as well as variable carbon. And then for that matter, when we talk of net zero target, our commitment towards environmental impact, computing GWP as well as other emission environmental impact has become a mandate as per regulatory requirements are concerned. And that's one of the reasons now every year in your annual report you will find all industries including transmission, distribution, generation, utilities to compute scope 1, scope 2, scope 3, as well as they also need to mention the target for minimization of scope 1, scope 2, scope 3. The moment you talk in these terms of scope 1, scope 2, scope 3, these couple of years like never before, obviously it's a data-driven tool and it has to be a data-driven computation. Now this is the indicative example of how with the help of life cycle assessment, gathering the required industry data from utility industry, we at TCS, we compute the landscape of presence of embodied carbon across substations. So this pie diagram is an example of, say for example, you gave an example of a national grid. We also work with national grid, but on a different, say, platform of digitization, creating a roadmap for their digitization journey. What is this? This particular pie chart helps customer utility to understand out of 100 substations, which are those substations that are high carbon intense. Now, any substation to become high carbon intense definitely has got relationship with the voltage level of that particular substation, the assets which are there in that substation, the aging of asset of that particular substation, the kind of overloading of the assets of substation that happens. So the operation of the equipments which are there in the substation also play very, very critical role in computing and deciding the emission of that particular substation. So it means at one click it is easy and possible for a utility to see the landscape of which are those critical substations where you need to prioritize on in terms of energy transition, in terms of decarbonization. Now, just to get a deep view, deep dive at any substation based on different assets that you have, it is very much possible to understand the embodied carbon as well as associated operational carbon with that particular asset. Now, in this diagram again, the indication is towards enlargement of switchgear. It happened so coincidentally after the talk of Hitachi that, we have a switchgear, and here that switchgear based on what type of dielectric material you have, based on the specifications, of course, there is an embodied carbon associated with it. However, embodied carbon probably we cannot take away. We have to accept that X amount of kg CO2 equivalent is associated with this asset. However, there is a lot of potential and opportunity to minimize operational carbon, where you really need to take care of that equipment from monitoring of performance of that equipment is concerned and actually undergoing the best of maintenance of that particular equipment. So this way you can actually create a roadmap for scheduling of the maintenance activity for the critical equipments. So see, the thing which are getting changed now is like we used to always think of electricity utility industry, say for example transformer or switchgear, from the point of view of failure analytics. Now, along with failure analytics, we really do the analytics of its presence of carbon because of its aging of that particular equipment. It means now sustainability has become a second side of the same coin, where we see on primary side the operation of that particular equipment. Now, another very important task that happens in our industry is civil works, which is associated with T&D primarily. Now, this civil work is also another very well documented activity by electricity utility across globe, where they seek for support of computing carbon and opportunity to decarbonize. If you see the construction industry, you will find construction industry talking about green cement, talking about actually trying to minimize using the resources while constructing any piece of work. So civil construction again can give you a kind of good amount of visibility towards what is the presence of GWP associated with transportation of the material that goes in that particular civil work, the heavy machinery that gets utilized during that tenure of construction activity, as well as electricity usage. I have not included water usage, but of course the other resources also gets consumed during that particular construction activity. Though it's a one-time activity, it is the construction that is owned by that particular utility for its lifetime. The good part of electricity assets are like they are robust assets. They do have a lifespan of 25 to 30 years. But what is known to us is like the performance of transformer at the year of installation and the performance of transformer at 25th year of its working years, you will find much more of deterioration in terms of dielectric strain, deterioration in terms of its loading capacity, change in terms of its losses. That itself comes under variable carbon component. And that's why we can look at all these assets and our electricity value chain through the lens of sustainability, because it has become today's priority. Again, transformer being a very, very popular asset for all of us as an electrical engineer, here comes another lens to look at transformer, not only from the point of view of working principle of transformer, its loading capacity, its failure, etc., but how much of GWP is associated with transformer. Various activities which are pertaining to transformer starts with use of land. The moment you use certain land for some specific purpose, the authority is answerable for change of land use as very important KPI. That's an environmental KPI. And that's why for substation, for transformer, for transmission lines, for transmission towers, for distribution cables, etc., you have land use as one of the activity. Then transportation of the supply chain while actually installing and having that installation and commissioning of substations, transformers, etc., that also gets accounted in terms of your contribution towards carbon footprint. Then the activity of erection, commissioning, installation of transformer plus the civil construction activity is another segment where you really need to know what is the value of GHG emission. And most important part where every utility nowadays is really making use of data, not only for understanding the performance of transformer, but understanding the operation of transformer, but to understand the operational GWP of that particular transformer, because in the use phase you need to know how many number of times the transformer failed, what kind of replacement of oil has happened, have you replaced couple of parts of that transformer, have you replaced winding, or have you replaced bushing, etc. And every part that undergoes material replacement is accountable towards your variable carbon, because getting that piece of bushing itself has got a downstream activities. So now things are so complexly interconnected to each other that one asset comes along with all these activities. And then the next picture also gives you a focus on use phase. So utilities, why use phase? Because transformer in the life condition comes under the distribution utility, under transmission utility. And then use phase is very important for utility to actually observe. Now in that case, again, you can bifurcate different activities during the operation of transformer, but here I have just considered 4. One is we need to know the power flow in that transformer, we need to know the power loss that's happening in the transformer, we need to know different kinds of repair and maintenance activities which happen in that transformer per year over the years for the total span of that particular transformer. And then obviously all kinds of activities which happen towards the transportation during the maintenance activity also comes under that. So this is how we need to visualize this particular activity of repair and maintenance and operation and maintenance of asset in this particular fashion. One. Second, here itself we get the opportunity to decarbonize ourselves. Now, many of the authors, they spoke about circularity, they spoke about circular economy, somebody mentioned of circular business. Here there is there is a need of ecosystem. The researcher from IIT Kanpur, he also mentioned about the need of ecosystem. We really need to have a strong ecosystem of OEMs, distributors, vendors, consumers. And then what happens to that particular asset at end of life is most important for all of us. And this is what is very much encouraged under sustainability driven initiatives, regulatory compliances, that once you are the user of any asset, you are also accountable for what do you do with that asset after end of life. And here is the example of what we can do to transformer at the end of asset, at the end of its life. And this end of life, which actually calls out for decommissioning of transformer, before decommissioning of transformer, there can be a trade-off between what is to be done, whether you can extend the life of transformer knowing the specifications and the performance of transformer, or you can buy back that particular transformer, or you can get the new transformer. And that's one of the reasons now the way you have green design, green manufacturing, green business, nowadays OEM themselves are creating another business portfolio of annual maintenance activity with all those vendors, where after certain span of working of those assets, they can be bought back to the manufacturing unit, and then certain parts would be repurposed, remanufactured. So refurbishment of certain parts is very much possible, and this is how we actually look at asset these days, along with our conventional way of looking at all the assets and utility. This is very, very important task for every industry, even including transmission and distribution utility, that is supply chain. When we procure material from suppliers, the way material comes to your door, that matters a lot, because whether that material comes to your door via road, via air, via sea, its carbon footprint and emission footprint is different. And that's one of the reason having set of suppliers procuring certain material from them, now there is a kind of an encouragement to talk to suppliers and engage them and involve them in our scope 3. Because scope 3 is something where it talks about the activities of associated stakeholders, and scope 3 emission is very complex but important for every utility industry to take care of. And then this is just a comparison, indicative comparison between 3 suppliers supplying you 3 different kinds of assets, and then you can understand which supplier has got less footprint, which has got more footprint, and then you can start negotiating and talking to the tier 1 supplier at least. This is exactly which we have been seeing across different regulatory commissions. Like in UK, when we say Ofgem has come up with absolute open data mandate. So when they have come up with open data, National Grid as well as other DSO and all the TSOs in UK, they have to publish this particular data on how are they taking care of involving their suppliers into their decarbonization journey. Energy transition is very well known to all of us. And here under sustainability space, when we talk of environmental KPIs, there is a very specific term that is called as materiality aspects. Now these materiality aspects are different, like they include safety of equipment, safety of personnel, they include governance aspect of operations, and they also include affordability of power, presence of skilled and happy workforce, and it definitely even try to make customer or say utility industry to compute is there any innovation happening in that company. And having many presenters coming from Hitachi, coming from Tata Power gives the justification that there is a complete R&D that goes, there is an innovation that is going on, and because of that we are able to get this materiality aspect. The other one are about how we take care of customer base. Here we have peer-to-peer trading, we have solar PV, and then we have e-mobility, we have E2V, and grid to vehicle connectivity. So all these opportunities of peer-to-peer trading as well as making use of this technology is absolutely comes under this umbrella of materiality aspects. And this is the last slide of my presentation, which gives you an umbrella of what all comes applicable to utility industry under sustainability, where we absolutely focus T&D, generation, utility. We do not have retail customer, but across globe we have retail business also. So they focus on environmental footprint, they focus on enhancing decarbonization, they focus on minimizing loss, pollution, leakage. The way we heard from Mr. Jain about SF6 leakage. And we focus on aging infrastructure, aging equipments, etc. And different materiality aspects completes the story of sustainability for utility industry with a very focused efforts on creating circularity and traceability to the materials which are replaced. And there is a kind of a debate that is going on that if I replace certain part which was there at a high voltage, if that is acceptable after test, can I use it at low voltage side so that I can reuse that particular, say, pin type insulator without throwing that out, because there is a cost involved in it, as well as it has not lost its life from operation point of view from low voltage side. So there are some such sort of a debates and deliberations going on across it. And as I just mentioned that we have these kind of reporting infrastructures like GRI, SASB, TCFD, TNFD, SBT, and these are all globally applicable regulatory compliances which are very well followed by all Indian utility industry, private as well as public also. So with this, my takeaway and the recommendations for this particular presentation or a session is like, yes, we have already transitioned a lot in terms of say technology. We are very much happy for Industry 4.0, Industry 5.0, but now it's a phase of sustainable Industry 4.0. And Fortunately, I got chance to attend COP28 as an IEEE delegation. I work with IEEE Climate Change Committee, where we actually work on developing technology solutions for sustainable climate. I'm also part of IEEE Smart City. So I know from city perspective what is the critical role of utility industry, because they are the backbone for every function that happens. But now the lens for everyone here has to be towards not only growth, transformation, and technology, but it has to be towards balancing the environmental concern and environmental impact. So simple, different dimension that we see today is like industry is already on the journey of digitalization, decarbonization, deregulation, and of course de-risking the threats of cyber. But all these 4 dimensions are very well acknowledged, provided we are really sensitive towards environmental impact, and we really look forward to contribute to sustainability driven initiatives. So with this, I'm at the last slide of references, and thank you very much. I'll be more than happy to take your questions, or you can reach out to me afterwards also. Thank you.
Thank you, Dr. Surekha.